We've been traveling for 3 or 4 days, halfway around the globe, with several hundred pounds of equipment and a team of 14 people, a multitude of partners spread over the entire region to bring you the most spectacular natural event witnessed by humankind. You're watching Slooh, and you're joining us to watch a total eclipse of the sun live from Indonesia.
Good Lord, ride all the way.
10,
9,
8,
7,
6,
5,
4,
3,
2,
1.
Welcome to Slooh's live coverage of the Indonesian total solar eclipse, or Gerhana Matahari Total, as they say here. Now, as we sit here on the rooftop of the Tadulako University on the outskirts of the capital of central Sulawesi, the moon's shadow is racing towards us at over 1,000 miles an hour behind us. It's going to makes landfall in the western parts of Indonesia shortly after. Then, from our location in Palu, we'll see the moon begin to cover our home star, the sun, at 28 minutes past the hour. Now, we've got several video feeds of the eclipse, both here at Palu, further north, where Justin NG's group will hopefully be providing spectacular images. We have a very special feed from the folks at Panasonic as well to share live from Ternate, Indonesia. We've also got the San Francisco Exploratorium Science Center on a tiny island in the aptly named Micronesia, and that's east of the main islands here. Now, our expedition partners at Chelios will be providing yet another feed from the university just here by the side of me, as well as the expedition's second location at Koto Hulu. Excuse the pronunciations of everything on the show today. Now, make sure that you watch the show at slooh.com so that you can use Slooh's Star Share camera. It's really cool. I tell you, you've got to go there, slooh.com, watch the show there. See, use the Star Share camera to snap and share your own eclipse images from some of those live feeds. So spread the word, share your images, and share your images on Twitter and Instagram by tagging into eclipses over millennia. And of course, you can ask us questions on Twitter with @Slooh. So pile forward your questions to us on Twitter @Slooh. Now, we are, as you've already experienced, we've seen a couple of little dropouts with the power here. It takes a little bit of time for the generator to kick back in. But stay with us, because we're here for 3 hours. We are going to be here all the way through from now until totality, and then from totality all the way through until the moon shadow leaves us here. Now, in the second half of the show, after totality, we are going to assemble our experts to discuss what we've seen, answer your questions. We're going to expand on some of the subjects that we cover during the first half of the show. And of course, we'll still have those live feeds until the partial phase of the eclipse is over. Now, we've been asked by a couple of Slooh members to share a little bit about our journey here and the preparations required to broadcast an eclipse around the world. We've still got time before the partial phase starts, so this is a great time to do just that. And to help me, I would like to introduce Slooh's Trisha Ennis, who is part of our expedition team, sitting right next to me. Hey Trish.
Hey Paul.
Trish.
Yeah, we're really enjoying this really long trek halfway across the world to Indonesia. I keep looking at you, but I know that our viewers can't see that. So so yeah, we're here. As Paul said, we are here to talk about the total solar eclipse live in Indonesia. I have just some weird things going on with my head right now. I have my solar eclipse glasses so I can watch the sun as it rises over the horizon. And then, of course, my regular glasses are over here somewhere. So I can shade up for the eclipse in more than one way. Now, Paul, I think we lost your connection a little bit at the end there, but I know that our viewers will be really excited to hear all about the really interesting guests that we have. As you said, Professor Lucy Green, and Bob Berman, and Eric Edelman, and everyone's coming on to talk all about eclipses and how they work, and the history surrounding eclipses. And it's all very fascinating, and I can't wait for you to see it all. Now, we did talk. We're in Indonesia.
flew basically to Barcelona. Now, Barcelona is where all of our Eclipse expedition team met up with our partners from our Tenerife Canary Islands Observatory. And we all met up in Barcelona, and then from Barcelona, we piled tons of gear into the aircraft and we flew out to Singapore. We had a few hours in Singapore before, just at the airport, unfortunately, before then flying on to a place called Makassar. We did stay there for one night, had a very early start. So we got on another flight and then we flew to Palu, which is where we are today. And you can see on these live images, sorry, those images that we took from the plane, large areas of flooding. I mean, this is the rainy season at this time of year, and large areas flooded. So a lot of people didn't travel to Indonesia. A lot of eclipse watchers didn't come down here. They decided to stay away because the likelihood was that we were going to have cloud. And I have to say, we've had really, really mixed reports all the time. And I came out this morning. So it's, what time is it, Trish, here?
It is 7:08 in the morning.
7:08. Now, we kind of surfaced about 4 o'clock, came outside, started setting the gear up, and frankly, it was totally clouded out. The first sign that we had was just above the mountains where we're seeing the sun. Venus popped up, and that was our cue to say, wow, we've got clear skies on the horizon. You're seeing here another team, another part of our team, who are actually working about 30 kilometers south of here. And we split the team up like that just to try and get around any of the weather. So I'm just going to see if Trish is back in the show.
Should be.
You should be. Well, Trish, what was the journey like? I mean, it was utterly exhausting, wasn't it? None of us slept.
No, none of us did sleep. We took a very long trip. Like you said, I think I had the longest trip. It was 7 hours on a plane from New York to Barcelona, 12 hours on a plane from Barcelona to Singapore, another 4 hours on a plane from Singapore to Makassar, and then another hour from Makassar to Palu, and that was Sunday. So yeah, we had some long journeys, some sleepless nights, I think, some sleepless days, really, and it was a long trip, but we did get to see a lot of different countries, and even if we just saw the airport or the hotel.
Absolutely, yeah. So how about last night then? You got plenty of sleep last night?
Oh, no sleep at all, Paul. None at all. You got more sleep than I did.
Well, sleep. I lay down. I did lay down for a couple of hours, I do admit. So host prerogative and all that. So anyway, listen, where are we? We have got, now we have got to say that a huge thank you to Tadulako University and the hospitality that they've shown us here. We met the rector yesterday, Professor Dr. Mohammed Basir CEO, and really they could not have extended more of a welcome to us. But Trish, you got anything to ask me on this?
On meeting the rector. Oh yes.
Well, no, on.
Sorry, I'm having a moment. Yeah, I'm actually wondering, what kind of provisions the university has actually supplied for us. How have you been feeling being here and doing the show here?
Well, they knew that we were bringing a lot of equipment, so they kind of set up big power cords, internet, all sorts of other stuff that we need for this. And you can see this is the meeting with the rector a couple of days ago, and they've just bent over backwards. We've done a few of these shows in remote sites, and it's felt like pushing water up a hill, really, to kind of get what we need. But they've bent over backwards, and today, would you believe, viewers, they have actually shut down the entire campus network to devote all of their bandwidth for us. I mean, how cool is that? I mean, there's going to be a lot of rioting students here, with no internet for some time. But, anyway. And the other thing we were going to talk about was actually the equipment, because we say we brought a ton of equipment. We've got telescopes, we've got cameras, we've got, between Trish and I, we've got 5 laptops here. So it's
I think we've literally brought a ton of equipment.
You got your microphone now?
I don't know actually if I've got my microphone.
I think Trisha has a microphone.
I don't know if I do or not. I have a microphone. Whether or not it's working, I am unsure. But yeah, I think we literally brought a metric ton of equipment with us, carried it on and off the plane. I had to pack everything into a tiny little bag so that we had the baggage space. But I think we got it all here. Nothing broke. So
Okay.
I think that's
Okay. Well, so we're good. And we're feeling pretty tired, and we are going to be so hot by the end of this show. I mean, the sun has just risen, about half an hour ago, and it's getting pretty toasty out here, I would say. Now what have we got? What have we got coming up, Trish?
we have actually. I'll take that microphone from you. We're gonna pass it back and forth because otherwise you are hearing both of us on both of our microphones, which is not good. We actually have some really interesting, and one of my favorite segments actually of this entire show is coming up next. Now we've come all the way to Indonesia with all this heavy equipment. We carried it on and off, broke our backs, got other people to help us because we didn't want to hurt ourselves anymore. But the big question is, why did we have to travel halfway across the world to see something happening to the sun? Which you can see the sun in like half the planet at any given time. It's always there. So why do total solar eclipses only happen in teeny tiny spaces? So we actually got some very special experts to explain this to us because we need some explaining right now.
We do, absolutely.
We do. We need to understand. So here to explain all of that, just how eclipses work, are some of our youngest experts, students from the Spire Legacy School in New York City.
Welcome to the Spire Legacy School in New York City. The third grade has been studying the solar system and learning about solar eclipses. What is a total solar eclipse? How often do they occur? Why did Slooh have to go all the way to Indonesia to see it? Why is it a total solar eclipse in Indonesia but only a partial solar eclipse in Hawaii?
Total solar eclipse is a cool mistake in nature.
It's when the moon gets between the Earth and the sun and the moon casts a shadow on the Earth. A solar eclipse can only happen at the phase of a new moon when the moon falls directly between the sun and the Earth, which makes an alignment.
The darkest part of the shadow, or the umbra, is almost as dark as night.
A place in which the shadow goes pitch black even in the middle of the day. Did you know that during a solar eclipse, the moon actually casts two shadows towards the Earth? One shadow is called the umbra, which becomes smaller as it reaches the Earth.
The second shadow is called the penumbra, which becomes larger as it reaches the Earth.
A total solar eclipse occurs approximately every 18 months. We had one in Kenya, November 2013.
One happened in March 2015 in the Faroe Islands.
Right now, one is happening in Indonesia. They don't occur very often because the orbit of the moon around the Earth is not in the same line as the equator. The orbit is at a tilt, so it only lines up with the sun once in a while.
Slooh had to go to Indonesia to witness the total solar eclipse this year.
They brought a lot of equipment with them to Indonesia.
They also have live streaming ginormous telescope in Indonesia and other places on Earth.
Because of the way the Earth is facing the moon and the sun, the umbra is only going to hit a certain spot on the Earth. For this eclipse, it is Indonesia and parts of the Pacific. The reason why there can be a total eclipse in Indonesia and a partial solar eclipse in Hawaii is because Indonesia is where the moon's shadow will fall.
The shadow, or the umbra, is actually very small compared to the moon.
The umbra is a very dark shadow.
For this eclipse, Indonesia lines up with the sun and the moon.
And the umbra will cast the land in the path of the eclipse into darkness.
Hawaii is not completely lined up with the sun and the moon, but it's not too far away from Indonesia. Only part of the moon's shadow will fall on Hawaii. In the rest of the world, either nothing happens or a partial solar eclipse occurs.
But if you want to witness it from New York, you won't be able to see the eclipse even a little bit because our part of the Earth will be facing towards the alignment of the sun and the moon.
Thank you for joining us. Keep watching the eclipse and keep your eyes on the sky.
How awesome was that? Thank you so much, kids. Many an astronomer, couldn't explain it that well. And I've spoken to a lot of astronomers, I assure you. Thanks to parents and teachers and students of the Spire Legacy School there, and a very special thanks to Malina Belafonte and Amanda Dara, who helped to organize that terrific feature. Now, if you love that as much as we did, and friends and family of yours haven't seen it, then we are going to be repeating that in the second half of the show, so please come back to see that. Now then, we are going to go into a little bit more detail with Slooh astronomer Bob Berman in the next segment, but I wanted to remind you of Slooh's Shade Up campaign. Now, what we ask you to do is show your enthusiasm for the eclipse by donning your shades and taking a shade up selfie and sharing them on Instagram using the hashtag Shade Up. Now, we launched the campaign at there's Trisha and somebody took that. Oh, Trisha took a selfie of herself, and that's me behind on the bus on the way from one airport to another. Anyway, we launched that campaign, the Shade Up campaign, at the New York Fashion Week. What a fabulous event that was. Before taking it to Oahu, that's the Hawaiian island of Oahu, for the Wanderlust Festival. Where they really took it up in good spirit as well. So we've had some great responses, so please keep them coming, and we will share some of our favorites throughout the shows. I especially, I put in order, please, for cat ones. Cat shade up selfies. Come on, we all know that's what the internet was designed for, strange cat photos. So I want to see your cat wearing sunglasses, please. So anyway, we are going to take a short commercial break, and when we come back, I'll be joined. Haha, look. Okay, well that's dogs. Okay, so I guess that's kind of good enough. Huskies. Love 'em. Anyway, we are going to take a short commercial break now, and when we come back, I'll be joined by Slooh astronomer Bob Berman talking about the sun and preparing for first contact, which is a mere kind of 5, 6, 7 minutes away. So we will be back right after this break.
Okay, we're having trouble with all the Skype boxes.
You got to Now it's 27.
And we actually have Bob Berman.
We do. Hey, great. Hello, Bob. Can you hear me? Oh, now say again, Bob. I didn't hear that, but I think I've got you now.
Yes, I hear you loud and clear.
Bob, that's great. Now listen, we had a few problems getting you in. We are what, about 5-6 minutes away from what's called first contact. What is it? What is first contact?
Well, I would say normally first contact is when the sun has its edge first touched and kissed by the encroaching moon. It's the first sign visually that something is really happening. But in this particular case, I'd say something bizarre is interfering with first contact, and that is the fact that the sky behind you looks so clear. Normally, we have to worry about whether the sky will be clear enough for the eclipse. This looks supernaturally beautiful. Can you explain that?
And here, Bob, for the first time, we've got our live video stream of the sun directly into the show. It's looking pretty good. Now, I think what we're going to be looking at is first contact is going to happen about at the 1 o'clock position on the sun's disk. So that's what we're looking at, and the moon is going to take that first little chunk out. But Bob, as you say, clear skies. I mean, look at this blue sky. What's going on? Total eclipse of the sun that I attend, and it's clear skies. This is maybe going to be my first clear sky totality.
Oh, I so hope so, and it certainly looks that way. In addition, and by the way, I'm struggling with some echoes, but I'm hoping they'll go away. Our own Eclipse Tour company that have gone to, as you know, about 9 of them in the past, decided to stay home and support Slooh as the Slooh astronomer here, that I'd be playing auxiliary role because the forecast, long-term forecast, was so not promising that I thought, Al, rather than go and have people disappointed, I'm just going to chicken out of this one and not bring people. And it looks like, but I was hoping against hope that you, Paul, would actually be able to see it. And who's with you? It looks like we have some other Slooh members too, right?
Yeah. Well, we've got Trisha. Trisha's next to me. She's manning telescopes and all sorts of stuff. And then we've got the other team. In fact, we've got quite a few. We'll show viewers later the people who are kind of starting to accumulate around us. But we've got 14 people in the eclipse expedition here, and we've got loads of people from the university who have popped up as well to watch the eclipse with us. Now, you may have heard, Bob, students at the Spire Legacy School, they told us about what causes eclipse and why they don't occur every month. But there's a wonderful cosmic coincidence that you and I have talked about before that specifically creates total solar eclipses from our viewpoint on Earth. And I think if I'm right, it's the only place in our solar system that sees a total solar eclipse. Is that right?
You're quite right. Now there are other places. The little caveat, the little star on that, and by the way, I'm still getting feedback. If you can get rid of that, Trish, is that there are other places that do see the sun fully blocked out by one of their moons. For example, Jupiter's Jovian satellites do exactly that. We can see areas that are completely blocked out by sunlight. They do experience total solar eclipses, but they they get too much of a good thing. Their moon is so big compared to how large their sun is in the sky that instead of just blocking out the perfectly the moon's the sun's edge and letting enough of the corona and the its in other words its atmosphere and flares and prominences and all the juicy stuff we're going to see, it blocks that out too. So it's too much, and you don't get the fabulous effects we get on Earth. So if what you mean is we're the only planet that gets perfect solar eclipses, where the sun and their moon, the planet's moon, appears neither too large, too small, too close, or too distant, yes, we're in the sweet spot. And we're the only ones in the sweet
Now,
spot.
Bob, We are, and we'll talk more about this cosmic coincidence of the size of the moon relative to the distance of that it is away from the sun. But we have got to warn viewers: keep watch. So we are expecting the partial phase of this total solar eclipse to start any second now. So we're watching this live video stream that is from these lovely cameras that we've got right next to us here. We're expecting to see a tiny nick to be taken out of the top right hand part of the sun. And Bob, what can we expect after that?
Aha, what can we expect? A complete change of life. You'll convert to a different religion. Yeah, we must fear for your wife, who's mythical anyway, because we haven't met her. We have to assume that many things are going to change in your life, because there are few events that visually will change a person forever, and a total eclipse is the only one. Proof of that is that some years later we had a beautiful event in Alaska of the Northern Lights, one of the best we've ever seen. About 40 participants
Yeah.
in Northern Alaska saw perfect, animated, colorful auroras. You couldn't ask for more. And yet, I asked a survey: how many of you have also seen a total solar
Oh,
eclipse?
Bob, Bob.
Well, interestingly enough, 23 out of 24 had journeyed to see a total solar eclipse. And you know something? And by the way, I see first contact. You can see
Yeah, we've got first
the
contact, Bob.
sun now
Yeah,
being
just
touched
seeing that.
by and guess what?
Fabulous.
23 out
Carry
of
on, Bob.
24 people picked a total solar eclipse as being far more spectacular than even the mythical Northern Lights. So that's way up there.
Wow. Well, that's especially, pertinent for myself and Trisha, because as you know, I've covered two eclipses, two total eclipses with Slooh, and both of them we've had kind of pretty cloudy conditions. But frankly, Bob, I know we shouldn't really say this, but conditions here are just looking absolutely perfect. So I
And
think I'm going to see
yes.
my first true totality.
Now, I'm going to give you, of all people, just because I've been to 9, I'm going to give you some like grandfatherly advice here. And that is, you have your
Please do.
professional cap on. You're the person who knows how to do this, and Trish as well, how to bring this view to the globe, to millions, if not billions of people. You have a responsibility to do this. You know, you want to narrate it, you want to help them explain what they're seeing. But this is like the attempt of trying to narrate the Big Bang, if you were there, or the Last Supper, or the creation of the Grand Canyon. Sure, you can go on, and you will with, "Oh my God, oh my God, oh my God." You know, you'll say things like that, but human words are inadequate to add to this
Yeah.
spectacle. They really are. So, you know, do what you wish, and I'm just telling the viewers that during our 2 minutes of totality, if there is some periods of silence during it, it does not mean that Paul or Trish have lost their tongues suddenly and have found themselves inarticulate. Even the great Bach, one of the great astronomers who went to I don't know how many with specialized equipment, for the final one of his lifetime, he sat under a tree. He used binoculars. He used none of his fancy
Yeah.
spectroscopes and all the other equipment. And he just drank in the glory of the eclipse just with his naked eye.
Yeah.
So this is one of those things that, my friends, what you're going to see and what's going to occur is beyond normal human experience. It just is. And so, as we try to narrate it, oh, here it is. That's the prominences. Look for that. You can see
Mhm.
one on the lower left. Oh, do you see that bright star? That's Venus to the upper right. Yeah, sure, we could give that information, but my goodness, if I had my druthers, I'd mention that during the lead up to the totality, and then during totality itself. Uh, it's a holy experience. So it's up to you to choose how much human language, and
Yeah.
science
Yeah.
to that you think might augment that.
Well, Bob, Trisha, and I, we've been sleep deprived for over a week now. So I expect actually all you'll hear is quiet sobbing, actually probably loud sobbing. Actually, now listen, Bob, we are going to be speaking to you shortly before totality, and maybe you can tell us then some of the things that Trisha and I and our viewers should be watching for during that phase. Now, right now, we are going to take a short commercial break. And when we come back, we have Slooh member's favorite solar physicist and BBC broadcaster, Professor Lucy Green. And she's going to be telling us about some of the phenomena we'll be able to see during the eclipse, including the chromosphere and prominences. So we will see you, and Bob, we'll see you back very shortly.
And I'm so glad even she's there. You know, she's only been to a couple of them in her whole life herself. So I can't tell you how glad I am that you guys, of all people, are there for this. It gladdens my heart more than you know. So yes, see you a bit later.
Y bueno, yo no sé a quién deberíamos agradecer que tengamos un clima.
I'm Professor Lucy Green and I'm a solar scientist working at UCL, University College London, and I specialise in studying the sun. That's been my object of fascination for almost 20 years now. Now, another exciting observation to look out for during a total solar eclipse is a special layer of the sun's atmosphere that's called the chromosphere. And this was a layer of the sun that wasn't possible to observe from the ground outside of times of solar eclipses for a long time. And now, if you want to be able to see it, you'll need to look during the time of totality, and perhaps just before and just after, but look for a red layer, very thin red layer that surrounds the disk of the moon. So this is the chromosphere. It's the layer of the sun's atmosphere that sits just above the visible surface, so just above that layer that's being blocked out by the moon. And its name comes from the fact that it has a very distinctive red color. So chromosphere, sphere of color. And that red color tells us something really interesting about the chromosphere, because the light is coming from a particular chemical element, and it's coming from hydrogen. So you can literally see the fact that the sun is made of hydrogen. Now, it's a beautiful ring to see, a beautiful red ring to see. But if you look carefully, and if you have a telescope to use, you might see that there are red clouds suspended up in the atmosphere of the sun just above the chromosphere. And for the Victorian astronomers, they called them red mountains. Today we would call them prominences. But the name Red Mountain actually isn't that inappropriate, because they contain the mass of a mountain, and sometimes we see them erupting into space. So if you're very lucky, you might capture that happening. But even if that's not the case, they are very, very beautiful to see. Now, the chromosphere is a really interesting layer of the sun to look at, and it's an important layer to look at during the time of a total solar eclipse. But so is the corona above it. And during the time of totality, it's still important for scientists to make observations and conduct research, because we can do things that we can't do from space-based observations. And one thing is that we can see much lower down in the sun's atmosphere than we can do using an artificial solar eclipse telescope in space. So we call those telescopes coronagraphs. But they block out much more of the sun's atmosphere. They have to have a disk which sort of replaces the moon, but which is much larger. So in the natural total solar eclipse, we can see lower down into the sun's atmosphere. And so during the times of totality, we like to have cameras that can take very fast series of images, and also very high spatial resolution images. And you can do studies that look for things like waves propagating through the sun's atmosphere. And they're very important because they carry energy from the lower region to the higher region, and they might be responsible for heating the sun's atmosphere. So in the chromosphere, the temperature is around tens of thousands of degrees, but higher up in the corona, the temperature is into millions of degrees. So looking for waves is one of the things that scientists will be doing during the total solar eclipse. So this one, but also ones in the future as well. And if you're very interested in taking observations yourself, this one is a great time to do a dress rehearsal for a project that will be running during the 2017 total solar eclipse that takes place in August. So there's a project called the Eclipse Mega Movie, and what scientists have realized is that total solar eclipses represent this unique opportunity to have a huge number of images, rapid sequence of images of the solar atmosphere in a way that we can't get from space. And so what we want to do is encourage people to take images and then submit them to become part of this much, much bigger movie. So have a practice on this year's solar eclipse.
I had to put my sunglasses back on, and now I can't actually see my screen to know that I'm back on. Thank you so much to Professor Lucy Green for that fascinating look at our sun. She will be back in just a little while. Paul is actually going to be sitting down with her to talk all about how solar scientists like herself use eclipses like today's to learn more about the sun. And we have distinguished, popular, and entertaining guests like Professor Green and like Slooh astronomer Bob Berman on all of our live shows all of the time here on Slooh. Live shows that wouldn't be possible without the generous support of our members. Now, if you aren't a Slooh member, you really should be. And I'm not just saying that because I work here. It's the best way to see the universe, short of actually jumping in a rocket yourself and going out there. Our members actually enjoy live telescope views from our global network of observatories every night. And they also get the chance to capture the universe live in our StarShare camera, which you can actually use today on slooh.com to take pictures from our live feeds of the solar eclipse. So you should come on over to Slooh, check out our StarShare camera, chat with our members in our chat room, ask us some questions, give us your feedback, and click on that little join button while you're here, just to give it a try. Now, we will be right back after this quick commercial break. And when we return, Paul will be explaining a bit about how you can watch an eclipse from your own backyard without doing damage to your eyes. And I'm actually going to go ahead and do that myself.
Hello and welcome back to Slooh's live coverage of the Indonesian total solar eclipse. You know, last night we were both, Trisha and I were kind of sitting here after, we don't want to bang on about it, but this is a huge amount of work. This is a huge enterprise to kind of do this, to come halfway around the world with all this equipment and then broadcast to the world like this. We were kind of feeling a little bit demoralized, mainly because of sleep deprivation. But really, I'm just looking out now and I'm seeing these clear blue skies, and we've got this wonderful image feed of the sun slowly being engulfed by the moon. And I must say, it's kind of made it all worthwhile. We're feeling a little bit more invigorated for the remainder of this show. And don't forget, we're going to be here at Totality, but we're also going to come back and assemble all of the experts that we've had on the show at the end. And you can ask us all questions. And share images. Now, please help us drum up support for this event by sharing your eclipse images, by tagging them with @Slooh. Excuse me. Don't let your friends and family miss such a wonderful live event. If you do, they'll never forgive you. Anyway, we've been looking at these great images, this live image feed. I'm just going to adjust it now. Every once in a while, you know, you may find that we stutter a little bit in what we're saying, and that's because we're looking after telescope feeds, we're looking after loads of systems and stuff like that. So do apologize if we, you know, we just come and go a little bit, seem a little bit distracted at times. We're doing it to make sure you still get these lovely images. And in fact, I can't stop looking at it. It's great. Anyway, so what we've been looking at these great images, but how are we doing it? You know, we know it's obviously extremely dangerous to look at the sun with your naked eyes, even for an instant. So to watch an eclipse, you have to have special glasses. And these are not normal sunglasses. You cannot use normal sunglasses to look at the sun at any point, let alone in an eclipse. So you have to use actually the glasses that Trish put on. And it's like these. These are the kind that you can get. These are the Slooh ones actually that we had made especially for all of the university staff here and anybody else who we could come across. We gave a whole stack to a load of school kids yesterday. So these things are special eclipse glasses, and you can look at the sun at any point, not just during an eclipse, but any time during those. And what I always recommend to people is test your eclipse glasses before you use them. And the best way of doing that is to look at an incandescent light bulb, you know, an old-fashioned light bulb, and just look at that through it. And if you see any pinholes of really bright light, then you don't want to use them. They're little pinpricks. But if you just see the lovely filament glowing, then you can use it. They're safe to use. The only time that you can ever safely watch the sun with naked eyes is during the moment of totality. Now here we've got nearly 2 minutes of totality. And one of the things that we have to do, we've told you that we have to actually whip this filter off. We've got a special filter, which is kind of like a big pair of eclipse glasses for the camera. And we have to take that off, otherwise we'd see nothing in totality because everything is going to go dark. We're going to be in the shade. You'll probably hardly see us. And what everybody looks forward to at totality is you get to see the corona, the outer atmosphere of the sun. So we're using special filters on this, so don't even point your own cameras at the sun without a special solar filter. Otherwise, you will fry your camera in a couple of seconds. So please don't do that. Now, we have got more information how and where to watch next year's great 2017 USA eclipse in the second half of the show. Bob's going to tell us everything about that. Where's the best place to watch? What's the best thing to do? You know, maybe it's maybe Bob's recommending that you should maybe go without your laptop to see that, maybe without your mobile phone. But make sure you take your mobile phone so that you can listen to Slooh's audio narration of that during that whole event. Now, I am joined by Trisha again, who is going to remind you about Slooh's Shade Up campaign. And as you can see, Trish, you're having a few problems there with bright sunshine, are you?
Yeah, I am. Now, I'm just going to get 1 second. And Paul, can you just let me know if I'm back on the air? We're having another little problem.
Yes, you're on air.
I am on air.
Yeah.
Great, I am on air. I just can't hear myself, which is probably a good thing. Probably a good thing. Yeah, I'm having a few issues seeing because the sun is right in front of my eyes and is blistering hot. The glasses that Paul was just talking about actually were melting on my face. So I had to take them off because that was getting uncomfortable. And I've got my regular sunglasses on, of course.
But you're not looking at the sun.
I'm not looking at the sun.
Thank you.
So I don't want to go blind. That would not be something I'd want to do up on a rooftop. But anyway, speaking of shades, by the way, because we have several kinds of shades out here. We have these shades, and Paul has his special eclipse glasses that actually look like glasses. And we have actually been running a
Oh, wow.
up.
Sorry, Trish. This is the first time.
The sun because of you.
Sorry, this is the first time I've actually seen it with my own eyes.
Oh. Well,
because I haven't put the glasses on before. Wow.
Oh.
Look at that.
Yeah, it is extremely cool.
I've just been watching our lovely live images on the screen. Cool. Sorry to interrupt.
That's all right. I've been looking up at it with these glasses. These are really fun, and these glasses are part of our Shade Up campaign, which we've been running for several weeks now. We actually launched the campaign at New York Fashion Week, which is a whole lot of fun. Lots of people getting involved and taking pictures with the glasses. And it's been a lot of fun since then. It's really spiraled and become a pretty cool movement with a lot of people taking some really interesting photos. We took the campaign to Oahu for the Wanderlust Yoga Festival. It's also been to some film festivals, and some college girls took it on a vacation with them and got some folks to take pictures. And it's really just been a lot of fun to see all these people so excited about the eclipse. And it even translated over here to Indonesia and to some of the different islands. And it's actually been really fascinating. We've had some great pictures. Here are some of our pictures. And we just love them. And if you want to get involved, you can still get involved with the Shade Up campaign. The eclipse is not over, and even after the eclipse is over, we've got another one next year. Shade Up all year long. All you have to do is put on some glasses. If you've got some eclipse glasses, even better. Grab your cell phone, take a selfie. I know you know how to do it. Upload it to Instagram. Hashtag Shade Up. And post it out there. If you can tag @Slooh on Instagram, on Twitter, we are finding and reposting all of our favorite images, and we would love to see yours. There are some really great ones. I love the kids doing it. I love the dogs doing it. Someone get me a cat doing it. We had a stuffed grumpy cat doing it, but I want a real cat doing it. I haven't gotten my cat to do it yet. I don't think he'd like it very much, but if you can get your cat to do it, I would be forever grateful. Now, Paul, you were going to tell us a little bit more about what it's like to be a Slooh member and just get even more involved in what's going on here at Slooh.
Indeed. I mean, we make no excuses, but no apologies for talking about Slooh and becoming a Slooh member, because it is so cool. We do it. We're a fairly small team here at Slooh, but we're small and dedicated, and we do it because we're passionate about it. And, one of the things about it is being able to share the wonders of the night sky and some of the technology sometimes, and doing a bit of astrophotography, telescopes, bit of tech, but also it's about the art as well, the art of astrophotography. Some members do quite a lot of science. They monitor near-earth asteroids. There was that one that was lost, if you remember. Atlantis, we called it, and it had disappeared. It had been discovered in 2013 and then lost for 6 years, and nobody was monitoring it. Well, that's what the Slooh Near-Earth Asteroid 18 do. They monitored these asteroids so they don't get lost, and that thing made a little close approach to us. I think it was on Sunday. Sorry, we're across the date line here, so we've been quite confused what day of the week it is. But anyway, so people do science using Slooh, but also some people just love sharing. They just love being in the community as well, of like-minded people. It's an open church, all views are welcome at Slooh. We have the tagline, space for everyone, and it could not be truer. For an internet site, where a community hangs out, we don't have trolls. I don't know why, but trolls don't come to us. It's just such a cool community, and I really do urge you to give it a go. Join today. Help us support. Put on events like this to bring this kind of spectacle, this amazing celestial spectacle, to everybody. You've seen that we get the kids involved. Oh, if you missed that, if you have joined the show late and you missed the presentation from the Spire Legacy School, we are going to be repeating that in the second half of the show. It is not to be missed. I think they're my new favorite Slooh astronomer experts. So anyway, come along, join the community. We need your support. We do an awful lot of work to bring all sorts of celestial events, including this one. Look at this. We've still got this big chunk of the sun being taken out as the moon slowly encroaches across it. Now, what's actually happening? I'll just digress here a little bit, because behind me, what you need to keep an eye on, if you see my webcam view, is the sky darkening over there. That's the west, immediately behind me. So we've got the sun, it's risen earlier, directly in front of us, and it's going to be so behind us is the west, and that's where, at this very moment, the moon's umbral shadow is racing towards us at 1,000 miles an hour. All right. So when it gets here, we're going to enjoy totality. And, well, we got a couple of scattered clouds, but they're nothing to worry about. When it gets here, I've got a sneaking suspicion that I may experience firsthand my first clear sky totality. And you are here to join us to do just that. I'm really excited, Trish. I'm sorry. I'm starting to get excited now. I feel like a excited schoolboy, with a new present. But anyway, I'll go back to what I was saying. Please check out the StarShare camera. Don't forget, when you join Slooh, you've got the community that you can join in. You can ask questions. There's no stupid questions in the Slooh community, right? It's really supportive. There are members there who are always willing to help. And it doesn't matter. You go onto the internet sometimes, you ask a question, and somebody, some troll comes up and says, "Oh, just search the forum and it's been asked before and have a look at the answer." No, we don't do that. We answer it again. It is such. I cannot explain just what a different type of community the Slooh community is, and you get to watch live telescope views from both of our observatories. We've got two. Our flagship observatory is at the Institute of Astrophysics in the Canary Islands, and actually some of our eclipse expedition here are from there. We're going to be interviewing Dr. Miguel Serra Ricart later. He actually manages that observatory site where Slooh has two enormous telescopes. And by the way, we are going to be finishing the installation of some special solar system telescopes as well, where you can follow Jupiter and Saturn and all the planets and the moon, of course. So you get to control those telescopes on a mountaintop from the comfort of your home. And also we have our Chile observatory, and that's important because that means it's a different sky. You get to see the southern hemisphere sky, and all members now can control the telescopes, and everybody can watch those live views from the telescopes every night. They can chat about them in the chat box, which is by the live views, and below it you've got our StarShare camera, and that's what we've made available free today for everybody during this wonderful solar eclipse, so that you can snap and share your own images of this event. But Slooh members use that every night to snap and share wonderful celestial images. Now, Trish, are we're a little bit ahead of time now, so I don't know, can we get Bob Berman back in? Is that a possibility?
I don't think we're going to be able to get Bob Berman right now, but you and I can actually talk for a little bit if you'd like.
Okay.
I know that you can change up our camera angle so you can actually see both of us.
I can indeed. Let me just do that. Folks at home, you won't know just actually how difficult this see the screen, because it all goes a bit glary, doesn't it? Now, Trish, are you going to be on this microphone as well with me?
I am going to be on that microphone with you. We are.
Okay, so we'll keep it in the middle and we'll talk loud, Trish.
We'll not keep it in front of the telescope, though, because that would be not a good picture. For our StarShare camera, people will think the eclipse already happened because the microphone is.
Okay, if anybody did snap that, then please send me the snap at paul@slooh.com after the event. I would like to see me handing the microphone over to Trish in front of the telescope.
Yes, I would like to see him make that mistake as well, because he's supposed to be the professional here.
Allegedly. Who said that? Who said that? I'll have words with them. I'll have words with them. So anyway, what questions have you got, Trish, about what we are going to see today? And I will do my best to answer them. If not, I'll pretend that the microphone has gone dead for a bit. And
and we just can't hear each other.
Yeah.
We're right next to each other, but we can't hear each other. I don't know what questions I have about the eclipse. I mean, I'm mostly just interested in the experience. I'm trying not to get too distracted by putting on my solar eclipse glasses and looking up, but it's really cool to watch.
Did viewers notice that as soon as Trish put the glasses up to her eyes? Well, she smiled, but also paused, because it's breathtaking, and don't forget, if you have not seen a total solar eclipse of your own, the most widely viewed one is going to be next year in the USA in 2017. So use this as your total solar eclipse of how to do it, where to go, and we are going to be giving you a whole stack of information on that a little bit later on in the second half of the show, actually.
Yeah, in the second half of the show, please stick around, because I'm actually extremely excited for next year's eclipse. I'm very excited for this year's eclipse too, but it's not taking away the excitement of actually being People are going to be pretty lucky.
Ooh, pretty.
Oh no, we're looking
Pretty.
at cool things again.
Yeah, I've just put my glasses on again. I'll tell you. Now, folks at home, these may look like normal sunglasses that I'm wearing, but they're not. They use the same material. So actually, if I look down, you can't see anything. You know, but if I look at the sun, they're very safe. And I have to say that it's an absolutely awesome view. I mean, it's awesome on the live video, but it's awesome in person too. And it is only going to get awesomer, isn't it?
Awesomer?
Awesomer.
Is that a word? Is it like gossamer?
It is now.
It is now.
It is now.
Paul Cox has coined the word awesomer. Bob Berman coined the word hemogenesis on our lunar eclipse show. So you have to top that now.
Well, listen, I mean, we're making up words now. We're adding words to the English dictionary, but about 4 hours ago.
Which English, though? American English or British English?
Definitely British. English.
English.
But, you know, it was only 4 hours ago that you and I could barely talk.
Mm-hmm.
Because we were kind of inside with very little sleep. In fact, you had no sleep last night.
None at all.
None at all, as you pointed out.
Yeah. Earlier in the show.
Earlier in the show.
Have you forgotten already?
Yeah, I've forgotten already that. So did you sleep well last night? Oh, you didn't? No.
No,
okay.
I didn't sleep well.
So anyway, come on.
Well last night?
What we have got, what you and I, Bob was very clear in his instruction. You know, we're not here on a jolly. This is not a holiday for us. This is not for us to see the eclipse. And that's why I haven't been looking, because actually it's quite distracting. It's so gorgeous.
It is definitely distracting.
We are here to bring it to all of our viewers who can't be here, you know. So yeah, you are going to have to forgive us though at Totality, because Bob was quite right. I did the Slooh Kenya eclipse. Now that was a heck of an expedition, kind of the same grueling thing as this one, but just in 4x4s and dirt roads and lots of dust for the cameras and telescopes and stuff like that. But I must say, we got this very small glimpse of Totality just through the clouds. The majority of the eclipse was clouded out. We also had a dust storm come over. And this one short moment had the most profound effect on me that I think anything in my life ever has. And even thinking about it now, Trish, you know, it brings a lump to my throat. So actually, you know, one of my biggest concerns today, I can almost feel myself welling up when I start thinking about the Kenya eclipse. Now, this is going to be full Totality that we're going to be seeing today. So yeah, viewers, you'll have to excuse us if we either go silent or we cry like babies.
I would say Paul will probably cry like a baby.
Okay.
And I will go silent.
Okay.
Trying not to laugh.
What?
Are
no.
you crying like a baby?
No. If that is your true reaction to a total solar eclipse, then either Bob Berman is lying, or you need to leave Indonesia on the first flight tonight.
Okay.
You'll be expelled from the country.
I seriously doubt that will be my response. But
okay.
No guarantee.
Trish, what have we got coming up in the show?
We actually have a lot of really great stuff coming up. We're just waiting on getting our connection set up to Professor Lucy Green.
Yep.
You actually already heard her earlier on the show. She's talking about the different kinds of phenomena you can see when you look at a total solar eclipse when it reaches totality, and you can actually see prominences and the chromosphere. Correct me if I'm wrong. Chromosphere, in different brilliant colors, and so we'll be looking for that, of course, when Totality reaches here. But she's actually going to come back and talk to us about how
she's coming back live.
She's coming back live.
Yeah, we're interviewing her live.
Live. We are interviewing her live. She's going to come back, and we're going to talk to her about the different ways that solar researchers like herself actually use solar eclipses to study the sun.
Yeah, and that has changed down the ages.
Yeah.
You know, it's a fascinating story, and hopefully, you know, Lucy will be able to share that. You know, what solar scientists or astronomers down the ages over the last 300 years really have used solar eclipses for, because one of them is a fairly basic one, which you know, some people know that it was the first time that the sun's corona, its outer atmosphere, was ever seen at a total eclipse. And in fact, they didn't even know if it was real when they first started to see it. You know, so that was, but we now have instruments where we can do that. But there is still a lot of solar science which is done, especially during total solar eclipses.
Yeah, so I'll be very interested to hear what Professor Green says about that, and and you know, some of the interesting things they're still learning about the sun, which we've had forever, and people have been looking at for a very long time and studying for a very long time. We actually got a viewer sent in a picture on Twitter. They seem to have photoshopped our shot of the sun as the largest game of Pac-Man ever.
Awesome.
I know I
Like
can't
it.
show it to our viewers, but they've taken this image of the sun that we have.
We'll get it in the second half of the show.
We'll try to get it in the second
Yeah,
half of the show, and they turned it into a giant game of Pac-Man, which was actually a very fun game.
Well, actually, talking of that, I'm going to take. It really is quite spectacular.
Yeah, I really hope they are too. We actually have a few different feeds. I'm not sure what the other feeds look like just now because ours has been so good. But there are several teams out here imaging the eclipse. We know we have one in Micronesia,
Yep.
from the Exploratorium in
San Francisco.
Yep, the Exploratorium Science Center.
Science Center.
That
yep.
is a mouthful. And there's also one from Panasonic is doing a show.
Yeah, they've gone right out into one of the eastern islands to do that. So.
But I know that the weather isn't as good in all locations as it is here. I know at the Panasonic feed this morning it was raining.
Wow.
And they didn't know if it was gonna break up. This morning we had clouds.
But you know, that's why they traveled that far out. I mean, they're using satellite technology to stream their feeds and stuff like that. But actually, I'm just listening to an aircraft, Trish, that's taken off behind us, and I'm thinking, what on earth is the view going to be like from up there? Because they're going to be above the clouds. They're probably going to be 36,000 feet. It's going to be crystal clear. They will probably see, if they're looking, the corona in more detail than any of us down here.
Now, do you think that the view actually changes? Like, is it still total when you're in the air?
Yes, it would be. It would change the timing. You would still have to be flying within this very narrow path. And the kids told us that in their presentation earlier on from the Spire Legacy School, that we've had to come to Indonesia and specific places in Indonesia because the shadow of the moon, which is racing towards us at the moment at 1,000 miles an hour, right, only has a width of about 100 miles. And you have to be within that very small zone to be able to see a total solar eclipse. You know, outside of that, there's a far larger area where you see a partial solar eclipse. And we had lined up our partners in Hawaii. They were going to be giving us their partial solar eclipse later, weren't they? But I think we got a bad weather report from them.
Yeah, we got a non-favorable weather report, I would say, from Hawaii. They checked in with us just a little while ago and said that they had a lot of clouds around. They were actually going to go to the summit of a mountain in order to get the highest possible view of this eclipse. And they were saying that there was a lot of cloud cover on the ground and that it was actually very high clouds. So they were worried that they weren't going to get very good views from the summit. And actually they checked in with us a few minutes ago and so they've gotten to the summit and it looks like they do have clouds, but it doesn't look like they've got total cloud cover yet.
Okay, and don't forget, you know, we've said that the shadow of the moon is racing towards us. They're further east, so the shadow of the moon is traveling at that ridiculous speed, supersonic. It's traveling, and it's traveling from west to east. And Hawaii is obviously a long way over, and that's why we had to come to this particular point. You know, this particular eclipse, the path of the total phase only hits landfall in a few locations in Indonesia. Then it races off into the Pacific Ocean, and they're not going to see the total in Hawaii, but hopefully, and it's after our show, isn't it? We're going to put a live feed though on at slooh.com at the normal page where members watch the live telescope views every single night, and it'll be on there. So if Hawaii does have clear skies, even if it's partially cloudy, actually it can look quite good when you just see a few. Sorry, I'm just going to adjust the telescope a bit because we're just losing the sun. Oh, this is starting to look ridiculously good. This is looking absolutely gorgeous. Now, actually, Trish, you know, to explain to viewers as well what's going to happen at Totality here, you know, we've got some fairly smart logistics to do here. You know, I'm going to be obviously trying to narrate our way through it, but as I say, probably going to be a gibbering, sobbing wreck, you know, sobbing on the desk. But you're going to have to switch over to. You're a bit nervous about this, aren't you?
A bit nervous about this, yes.
Because this is the money shot. This is.
I can't screw this up.
No, you have got to remove this special solar filter that we've got on this wonderful little setup that we've got here, so that we can see totality. Because if we left this filter on at totality, there's so little light that we won't see anything at all. Now then, what you've also got to do is you've got to change the exposure time. I actually, viewers, what I'm doing here is I'm kind of dressing this up as, you know, information for you, but actually it's Trisha's instructions.
You don't trust me after my night of sleep.
No, yeah. That's it. I trust you normally, but not after a night of sleeplessness. So you're going to have to be changing the exposure time. So we've got totality of, I think it's 1 minute, 47 seconds or thereabouts. Now there's going to be some faffing around at the beginning, some faffing around at the end, because what I haven't told you is, if faffing, that's a good word, isn't it? If you don't put this solar filter back on the camera when totality ends, you've burnt my camera up.
Oh no.
In which case you won't be flying back to the USA, you'll be walking or swimming. Actually.
If I can walk on water, we'll have totally different issues. Now, actually, that's a great place to leave this, because I've just heard from our studio that Professor Lucy Green is available. We are going to take a quick commercial break, and then Paul is going to talk to her about the just amazing things that you're able to learn about the sun by watching solar eclipses and by looking through telescopes at the sun with special filters. So we will be right back after this.
We are delighted to welcome back to Slooh our favorite solar physicist, Professor Lucy Green. Hello, Lucy, can you hear me?
I can hear you. Hi.
Great. We've got a little bit of a time delay, but we've dealt with that before. And now I've got to ask you in the first instance, what do you make of these live images?
They are fantastic. I was so pleased to see first contact, and I was looking on the sun, where is the moon going to appear? And then I just saw it coming in from the top of the image, and you've got an amazingly clear sky. I'm so envious of you being over there.
I know. Well, you've traveled to a lot of solar. By the way, if you can, Lucy, switch your video on. That would be great. But if not, don't worry. But you know, you've been to quite a few solar eclipses, haven't you?
Well, I've only seen one total eclipse successfully, and that was the total eclipse in 2009. So this longest eclipse of the century, and I was on a ship on the Pacific Ocean, and I managed to see that luckily. But then the first eclipse that I tried to see was the eclipse that was visible in the UK, so down in the southwest of England in 1999. Yes. But that one was completely clouded out.
Indeed, yes, I remember it well, very well. So now, before we actually ask you to tell us a little bit about some of the phenomena that we're going to see, we really like to understand what inspires anybody who's into science and astronomy and stuff like that. What inspired them to actually get involved with it to begin with? You know, some of us had a fantastic science teacher or something like that. Other, parents, other just picked up a book in a library. What was it that inspired you to get into science and specifically the study of the sun?
Yeah, that's a good question, and I've often reflected on that. Was it something, inherent in the way that my mind works, or was it something that happened when I was a young child that got me interested? And I think that the fact that I grew up in the countryside was quite important, because I was always interested in going outdoors, asking questions about the natural world, And actually, the thing I really loved to do was ask questions and then collect data to try and answer those questions. So I was quite interested in wildlife. I'm sure many children start off that way. But then later on in secondary school, when you start to have your science lessons, I just got completely fascinated by physics. And I loved the fact that you could use this logical approach to answer your questions. And then that led on to a love of physics. And I went to university. But the turning point for me to start studying the sun was actually a trip to the Crimean Astrophysical Observatory. And I actually went over there with a group of students to do some observations as an undergraduate, observing particular binary systems. But while I was over there, one of the ladies who worked there actually, and she was running one of the solar telescopes, and she said, oh, well, come and have a look at my facility. And she showed me a view of the sun through her specialist telescope, and I was completely captivated. I'd never seen any images of the sun before through a specialist filter, and it was so different to what I expected it to be. And that's what we're going to see when the total phase of the eclipse happens, that you see the sun transformed from the yellow disk in the sky that we're all familiar with to something that we rarely get to glimpse. And that was the turning point for me.
Wow, so it kind of is very similar to quite a few Slooh members actually that I've talked to. That it's that kind of inquisitive nature as a child, and it just grows and grows, and then it grows into a thirst for knowledge and understanding. But so what have we got to look forward to here, and what have scientists done down the ages, over the last few hundred years? Why have total solar eclipses been so important for solar studies for solar scientists?
Yeah, it's a really good question, because you think, well, we get to see the sun all the time, so why can't we just do our studies during normal days?
Yes.
But actually, during a total solar eclipse, because you get this rare opportunity, or, well, indeed, it used to be a rare opportunity, now we can recreate it with modern space telescopes, to see the atmosphere of the sun. So we're so dazzled by the light coming from the photosphere that we don't get the opportunity to distinguish light that tells us about the sun's atmosphere. So we get to see about the visible surface of the sun, but not the atmosphere. And that's what we need the solar eclipses for. And I was interested when you were talking earlier about the fact that it was only fairly recently that we realized that this glow around the moon that you see during the total phase is actually coming or revealing to us that the sun has this extended atmosphere. And it was interesting that great astronomers like Kepler in the 15 and 1600s, and even Edmund Halley into the 1700s, they weren't sure if that glow around the moon's disk was for the sun, or was it from the Earth's atmosphere, or was it even the atmosphere of the moon? And so it was only really coming into the 1800s that we started to realize, actually, that's something that's associated with the sun.
But as you say, we can now recreate with special instruments. We can block out the actual solar disk, and we can study the corona, and also we've got space solar telescopes, of course. So is there any work that scientists can still do during a total solar eclipse?
There really is. And so it's interesting to talk about the fact that we have this modern instrumentation that allows us to recreate a solar eclipse, and we produce an artificial solar eclipse. But those instruments are actually quite limited. And although they allow us to see the corona, they don't allow us to see to the very bottom of the corona, or at least not very easily. So when you think about a natural solar eclipse and the moon moving in front of the sun, we talk about the fact that the moon is exactly the same size as the sun, so it perfectly blocks out the photosphere. But when we're building a telescope to do that, we tend to make the disk that is the artificial moon a lot bigger than the size of the sun. So we lose some of the sun's atmosphere. It covers up the photosphere, and it covers up some of the atmosphere as well. But so what we need to do is observe the total phase of natural solar eclipses to get down to the bottom of the sun's atmosphere.
Oh, okay. I didn't realize that.
Lots of interesting things happening.
Yes. Okay, so I didn't realize that was still the case, that we lost some of that lower atmosphere detail. Now, have you heard of the International Occultation Timing Association? Because I believe they still do some work, and that they're trying to measure very precisely when this phenomena called Bailey's beads appear, come and go, because they're trying to study whether or not the sun is just puffing up and going down a little bit over time. Surely you've got better instruments that can do that, haven't you, to be able to measure that?
It's a really, really difficult thing to measure. It's interesting that you raise that, because that's the question that
Oh,
we
is
want
it?
to understand. Is the size of the sun
Ah,
varying? But also, is the sun slightly fatter around its equator than it is if you go from pole to pole? So is it a
yeah,
perfect sphere, or is it a squashed sphere? And that's the kind of thing that you
yeah.
could investigate using these occultation approaches. But the changes are so very, very tiny that it's very hard to do with the telescopes that we use. And I've certainly read papers about this in the past, and I've read papers that say that the sun is a perfect sphere, and I've read results that suggest that the sun isn't a perfect sphere. So you can see it's still a question
Oh, that's
that needs to be
fascinating.
answered.
But isn't that one of the lovely things that, most of us who are passionate about astronomy, it's one of the great things. There are so many unanswered questions. And the great thing about science is, and scientists, we're never afraid to turn around and say, actually, we don't know, but we're trying to find out.
Absolutely. And if the scientists don't say that about their own work, other scientists will say it about other people's work. So, that's the way that science progresses, that I might write a paper and then other people in the community will say, well, actually, I'm not sure about that, and vice versa. And you need that discussion and you need that debate to push the ideas
Yeah.
forward.
Yeah. Yeah, that peer review of testing your own and others' theories is
That's
just
right.
absolutely fundamental to the whole of science. Now, you did mention that you witnessed the total solar eclipse in 2009 in China, but you did it actually from the Pacific, you said. Now, what was did you have an emotional reaction to that, Lucy, or were you really viewing it, with your solar physicist hat on?
Yeah, I was interested to listen to your conversations earlier about the reaction that you're expecting to have, because I did I did have an emotional reaction, but it was sort of with a delayed onset. So I watched the total
Oh,
phase after having, built up for so long the expectation of wanting to suddenly, be able to see the sun with my own eyes after having studied it for all those years. But it was so overwhelming that it was probably, I don't know, an hour or two afterwards that I had the emotional reaction. I don't know, it was so overwhelming. It was when I was back in the cabin of the ship. So after the eclipse was completely over, that was when I sort of had a bit of a moment. I thought, wow, that was absolutely amazing. And I completely understand why people chase eclipses around the world. And in fact, one of my friends, who's also a solar physicist, is in Indonesia at the moment. And I spoke to him earlier on today to say, oh, what scientific experiments are you going to be running? And he said, no, I'm just down here to see the eclipse and take some photos.
wonderful.
So as a solar scientist,
Wonderful.
yes, we want to do the research, but we also just get obsessed by seeing the sun anyway.
Absolutely. Well, you did your blubbing in private. I'm probably going to be doing it in front of millions of viewers. So, I have already apologized for it. But Lucy, it's always fabulous to have you on a Slooh show. Thank you so much for your insight. And hopefully we might see you back. We might get you back on one of our 2 weekly, actually we hold 2 a week, solar shows with live solar views from our Prescott Observatory in Arizona, our partner. So Lucy, thank you very much for joining us today.
Yeah, thank you. Enjoy the eclipse.
We will. Now, that was Professor Lucy Green, solar physicist, favorite of Slooh members and also a lot of BBC TV viewers. Coming up, we have Slooh astronomer Eric Edelman, who is going to take us back in time to an ancient war that was suddenly stopped by an eclipse. And after that, Professor Lucy Green is back in the minutes before totality to give us a little pre-recorded segment to tell us about the amazing phenomena that are Bailey's beads and the diamond ring. So this is over to Eric for a little bit of mythology about a solar eclipse.
Hi everyone, I'm Eric Edelman from Down to Earth, and I'm here to bring this eclipse a little bit more down to earth. Not literally, of course, but isn't there something magnetic about an eclipse like this? Our sun is such a constant in our sky. We don't actually look at it unless achieving blindness is on the bucket list, but evidence of it being up there is everywhere in our lives. Even at night, we see the moon because it is reflecting light from the sun back at us. Then, all of a sudden, for a few minutes on a very specific day on a small chunk of the earth, everything changes. The light vanishes and the sun is gone. We know why it happens. We know this is the moon passing in front of the sun. We've seen the man behind the curtain. We can even predict these eclipses years and years and years in advance now. We've got them, as they say, in the bag. Even so, they are still absolutely magical to witness. Talk to anybody who has seen a total solar eclipse, and they will tell you, and they will keep telling you, and keep telling you. If it's amazing even knowing all that we know, just imagine what it would be like if you had no idea what was going on. Well, some historians say that an ancient eclipse was mind-boggling enough for some people that it actually ended a war. This eclipse is known as the Eclipse of Thales and occurred in approximately 585 BC, or so the story goes. About a century later, Herodotus, a Greek historian, wrote down the tale of this eclipse and about what a ruckus that it caused. There was a skirmish going on in Central Asia at the time between the Medes, or ancient Iranians, and Lydians, a group that resided around where modern Turkey is today. These two groups had been at war for years. Why? Well, one reason being fighting over some land, as people do. The other reason being that the Medes hired some hunters who didn't work out that well, and the king of the Medes ended up insulting these guys. In response, these hunters killed one of the king's sons, as is normally how things escalate when one is insulted, and they ran away to Lydia. The Medes asked the Lydians to give these guys back. The Lydians said no, and so it sort of turned into this US Russia Edward Snowden sort of deal, except Snowden didn't kill anybody, and the United States and Russia didn't go to war over him. The Lydians and the Medes did. They fought and they fought for about half a decade until the Battle of Hales. Now, here is what Herodotus says about the battle in the history of Herodotus. Another combat took place in the 6th year, in the course of which, just as the battle was growing warm, day was on a sudden changed into night. The Medes and the Lydians, when they observed the change, ceased fighting and were alike anxious to have terms of peace agreed upon. Now, we can't be sure exactly what was going through the minds of these two peoples when this eclipse suddenly happened, but I like to think that it might have been similar to some rowdy kids who all of a sudden see the light flicking on and off above their heads and turn to see a disapproving parent flicking the light switch. Guys, cut it out. Time to stop. One incredible thing about this story is that just as we can very accurately predict future eclipses, we can also trace them back into the past because of what we know about the orbits of the sun and the moon and ourselves. NASA has a map that shows an eclipse that happened just about the time of this war and that would have occurred right around the place where the battle was being fought, near modern-day Turkey. This isn't proof that this story absolutely happened, though, as Herodotus said, but it does mean that it was very possible. I've been trying to think of a reasonable modern day equivalent to this, some sort of image that could inspire in you or me the same sort of awe and terror that stops wars, or the equivalent for us of what this man feels when he sees a lizard on his shoulder. Same sort of thing. I thought it would be sort of like seeing a different color. And I'm not talking about you seeing green instead of blue or anything like that. Nothing that could be made from the primary colors or from your imagination of experiencing color up till now. A new color that all of a sudden covered the sky with no prior warning or explanation. Maybe, just maybe, that could end up stopping a few modern battles or two. Who knows? Let us know in the hashtag at Twitter if you have an idea of what could mystify us like eclipses did back in the day. At any rate, it's about time I got you back to the Slooh expedition team. Thanks for listening, and I'll be on later in the broadcast to talk about an eclipse that helped prove to us that Einstein's theories didn't just talk the talk, but that they could walk the walk too. See you in a bit.
I'm Professor Lucy Green, and I'm a solar scientist working at UCL, University College London, and I specialise in studying the sun. That's been my object of fascination for almost 20 years now. Now, during a total solar eclipse, there are a couple of things that I like to look out for, and they're phenomena called Baily's beads and the diamond ring. And they happen just as the moon is sliding completely in front of the sun, so just before totality, and then again just after totality. So if we think about those times, the moon is moving in front of the sun, but hasn't quite blocked it up completely. And so what you see is sunlight that looks like a crescent just peeking over the side of the moon, and that light reduces as totality approaches. But what's really interesting is that it's not a nice clear crescent. As it starts to reduce, you'll be able to see that there are bright patches of light looking like a string of beads around the edge of the moon, and that's something that's called Baily's beads. Now, they only last for a few seconds, and to see them you'll need to keep the solar viewers on your eyes because you're still looking at sunlight. So don't take the safe solar viewers off until you've got totality happening. But as the Baily's beads start to reduce, you can get to a point where you have one bright bead and then the corona of the sun peeking over around the rest of the moon, and then you have the diamond ring, and that is the iconic image of the of a total solar eclipse that people try and capture. It looks absolutely beautiful. But why do we get these kind of observations? Well, it comes from the fact that the moon isn't a perfectly smooth object. It has craters on the surface and it has mountains on the surface. And in fact, you can get a feeling for that if you look at the moon outside of the times of a total solar eclipse, and you can see shadows cast by these features. But during a total solar eclipse, the light is able to peek through the valleys between the mountains and between the craters, and that's what gives you either the Baily's beads effect or the diamond ring effect. And it's interesting because it wasn't fully understood why those phenomena happen until around the 1830s, and it was a British astronomer who made this discovery, Baily, and it's named after him. So he was the person who accurately described and understood that this string of beads that you see is caused by the rugged surface of the moon. So it might be mountains that are up to a few kilometers high, and then that blocks some of the light, but in the gaps between the mountains some of the light manages to come through. So they sound like quite high mountains, a few kilometers high, but they're still less than 0.1% of the diameter of the moon. So they're pretty hard to spot with a telescope, and so you can sort of understand why they weren't, or why it wasn't understood until the mid 1830s that it was lunar mountains and the rugged lunar surface causing these features.
Hello and welcome back. Folks know that we are a small but dedicated team at Slooh. We're passionate about sharing the wonders of the night sky. And in fact, we're going to get a little picture not only of the people that we're sharing this eclipse with online, you, but also the people here who have joined us up on the roof of the university in Indonesia. We're in the capital city of central Sulawesi in Indonesia. It's called Palu. And the folks here have been so generous with their hospitality. We're at the Tadulaku University, and Professor Dr. Mohammed Basir, CEO, welcomed us with open arms, and his staff have been absolutely wonderful from the moment we arrived. So huge thanks to them. But anyway, you know, we are passionate about sharing the wonders of the night sky at Slooh, and sorry if it comes across a bit cheesy, but we really mean it. We love doing it, and it's not just science that attracts us to looking at the night sky. As we look at these gorgeous live images of this becoming very, very thin crescent moon. Now, don't forget, we've got other feeds coming in, and I did see from our team, Justin NG's team, slightly further north in Palu from us, they've got some wonderful images coming through. They look white, very, very crisp images, look absolutely brilliant. Now, so they do science, a lot of science, you do looking at the night sky. it can be fun, but it can be as simple as feeling a sense of wonder and awe, at the vastness of space, or maybe contemplating our place in the universe. Whatever's brought you here today, whatever your connection is to space, you've come to the right place. Slooh. Some Slooh members, they do science with the telescopes. I told you about that earlier on. But many members simply enjoy watching and snapping and sharing beautiful images of comets, nebulae, galaxies, anything in the night sky. That's what Slooh members watch, and they control the telescopes. If you join today, you can control the telescopes tonight and point it to whatever celestial object you want. It's great fun. It's a lot easier than you think. And if you do get stuck, we've got great support, not only from us, but also from the Slooh community, the community of members. We cannot stress just how strong and wonderful those members are. And, part of it is they are here because they're supporting Slooh, and we really need you to as well, so that we can carry on with our mission to share the night sky. Now, as I talk now, suddenly I can feel darkness falling around me. I'm looking over to the west, and I'm not seeing anything there, but I noticed and I've just caught a tiny glimpse of the sun with my naked eye. Please don't do that. But you can very much see that it's got a large chunk out. Anyway, please join Slooh. I am going to pull back in Bob Berman, Slooh astronomer Bob Berman, into the show to put us back on track, to tell us what's going to be happening. We've got about 5 minutes to totality. So Bob is going to share with us. Bob, I'm already emotional.
I'm so excited for you guys. When we think about what's happening, here is the moon going around Earth at 2,289 miles an hour. That's pretty fast, but at the same time, Earth is spinning under it at about 2,000 miles an hour. So the combination of those two speeds mean that if you're close to the equator, as you are, Paul, you get a longer eclipse, because as the moon's shadow speeds over Earth, you're on the fastest part of Earth, speeding in the same direction. And that, fortunately, prolongs the event. And you're absolutely right. You've been talking about the science. I've been hearing wonderful science from Lucy Green. Fantastic poetry coming from Eric, our Slooh astronomer. Poetry of a level that I'd play everything that he said. I'd record it and almost make that into my home bell when people ring the front door. I'd love to hear that thing all over again, because it was just so gorgeous. So, I'm going to stop speaking at totality or around that same time, but in the couple of minutes left, suffice to say, we have a combination plate. It's a magical marriage of science and, I won't call it philosophy. Let's call it something closer and take this in the right term, please. Holiness, sacredness. This is a sacred experience, because it's one thing to know that the moon is going around Earth. We all know that. We all know that. But it's another thing to look up in the sky and see the actual tick-tock clockwork motion of the solar system as it affects us. Now, in these final 2 minutes, Paul, since you've been clouded out of a couple of eclipses, one thing to look for, and if you're in a place that you can see it as a deep partial eclipse, look at the light on the Earth below. Sure, everybody's staring at the sun, but just for the moment, don't look at the sun. Of course, you're staring at the sun with eye protection, but I mean, don't look toward the sun. Look around you. Look at the tables, look at the shadows, look at any buildings, and you'll see that in these final 1.5 minutes before totality, the nature of sunlight changes dramatically. It gets more saturated, the colors get deeper, the edges of shadows, instead of having the blurriness that shadows always have because they're being cast by a 1/2 degree light source, instead the edges of shadows become sharper and sharper and sharper. Maybe you could even have a camera that shows that, but if you don't, Paul and Trish and all of our Slooh team there that have gone through so much work to bring this event. And you did not chicken out the way I did for the last cloudy eclipse. You went right ahead, thanks to Mike Palucci, who spends no small amount of time and effort and personnel to bring these to the world. Yes.
Bob, I have to stop you there because we are now seeing the diamond ring. It's extraordinary on our live video stream. And what Bob was talking about, there's this steely blue darkness that's around us. It's incredible. Wow.
And look at the
I've just seen
shadows.
Venus.
Look at the remaining. Look at the remaining light before it's gone.
Venus has,
look at the remaining sunlight on all earthly objects, and that remaining sunlight is a thing unto itself. That will disappear. There you go.
Bob, we are at totality. Listen, I'm going to take over here, Bob. Venus is shining brightly. We've got totality here. It looks absolutely extraordinary. I can even see Mercury now. I can see Mercury between Venus and the sun and moon, and there we sit. Now, I can't see with my eyes any prominences. I can't, yes, I think I can now, Bob, see some corona. It's really difficult to take out. We have got perfect conditions here. Look at this live video that we've got. You're seeing it live on your screens. It is absolutely remarkable. I can't, wow. It's getting darker and darker now. I mean, you can see the scene behind me. Everybody is having great fun. Hold on 1 second.
I need your help. I need you to do this. Hi everybody, this is Trisha. I'm taking over. Actually, I think I might have actually gotten the thing that I was trying to do. I was having a panic attack. This is incredible. This
wow,
is
we've got the money shot. It is the most extraordinary sight here. You know, even on screen, I mean, it looks stunning, but I can't describe to you how.
Binoculars, just for a few seconds, grab those binoculars and look at the sun. Quite safe to do. Do yourself a favor and just have one shot with a little extra magnification there, and see what you see. Oh, I see.
Well, actually, Bob, I can now see prominences. They are beautiful. Wow.
Yes, beautiful pink.
Oh, that is wonderful. Look at that. And there, is this a diamond ring starting again? Wow, that is the most beautiful thing I've ever seen. Wow.
Glasses, please. Now, glasses.
Wow. Trish, what do you make of that?
Well, it actually is extremely incredible. I don't know if I'm breathless because of the eclipse, which was so beautiful, or because I'm trying to make sure that our folks watching at home are able to take photos of the diamond ring. Of course, I'm staring at the sun now as the moon is starting to move away, and I'm going blind doing it. It's absolutely incredible. I'm so glad we were able to get great photos in our StarShare camera. If you are on Slooh.com, there should be a great photo for you to share. Share it on Facebook, on Twitter, on Instagram. Download it to your phone. I'm going to hand this back to Paul so I don't start yelling.
Wow. And Trish is also going to remember to cover up my very expensive camera as well with the solar filter
again. Because that will disappear. You may
I know. Bob,
bands.
it's this steely. Yeah. It's this steely grey that it's a color. It's a hue that I couldn't describe properly, but the best I can do is kind of a steely blue.
Right.
Yeah,
what it's
absolutely.
Like, it's as if Earth is being illuminated by a different kind of star than the sun.
Yeah. So what's happening, Bob? What's actually causing that?
But because all the sunlight is coming exclusively from the limb of the sun, we're getting totally different effects than you would as if the full half degree of the sun were providing the illumination. So, among other things, hold out your hand and look at the shadow of your hand on the table, and you'll see it has sharp edges instead of the usual blurry edge that a shadow has. You'll see the colors around you, like on buildings and such, are much more saturated than they normally are. So it's sure the sunlight has returned in one sense, but in another sense, we're not quite
Ah,
back yet to a normal sun.
I'm also looking off in the distance, Bob, and there's a wow. They've just flicked off actually. I noticed that there's a big housing estate there, and all of the lights had gone. All of the street lights had come on because they're automatic, and they've just flicked off again. Kind of, I can't actually believe, that we've reached this stage. It's gone so quickly. I think we've been on air for an hour and a half.
I don't remember anymore. Yes, an
Trish
hour and
doesn't remember
42
either.
minutes.
An hour and 42 minutes. I mean,
Not to
it's
mention days
I
of
can't
travel,
quite.
correct? Days of
Absolutely. I
travel
mean, we set off
to bring
last week, but Bob, I am so glad that you were able to join us for this total solar eclipse of the sun from
Oh, I'm so
Indonesia.
glad too, but I'm
My
especially glad, Paul, that you've been there now for a totally clear total solar eclipse. I think you'd
Absolutely,
agree that
and
this one is superior to the overcast one.
oh yes, and we are going to talk about that. I want to now that I have experienced it for myself. I've read an awful lot about this. Partial solar eclipses are nothing. They're like they're just no comparison whatsoever. Now I've experienced both myself. I totally get what you're saying, but we'll talk about more of that when we get together. Trish, you and I get together, and don't forget, viewers, you can ask us questions to Twitter using @Slooh. Trish.
Yes, @Slooh on Twitter will get you questions. You can also come to slooh.com and join our chat room. Lots of people in the chat room ask us questions, and we'll try to answer as many as we can for the end of the last bit of the partial phase.
Yeah.
Now, I'm going to also be working at trying to make sure that everybody on slooh.com is getting great images in the StarShare camera. So we will make sure you're here, take some photos. We'll have
Yes,
a
and
great time.
meantime, beginners are used to the word eclipse, and they may not realize that there are penumbral lunar eclipses and partial lunar eclipses, and there are total lunar eclipses, total solar eclipses. There are a variety, and frankly, they range from ho hum, a penumbral lunar eclipse you barely can tell anything is happening, to even a total lunar eclipse. We enjoy them. And so, of course, we bring them to the sky. The media has increasingly called those the blood moon. And there's something very cool about watching the moon turn that deep, ruddy color. But when it comes to the world of eclipses, if this is 100, if you'd rate a total solar eclipse as 100, what number value, Paul and Trish, would you give to the next best eclipse of the kind that we bring to the public?
It's just been incredible. I mean, we've just switched the view back to us, but I hope you all enjoyed seeing the other people here who were looking at. Trish is just handing out actually some more solar glasses. For people who haven't got those. We've got some kids here. In fact, we've got loads of university students here. Bob, we are going to see you in about 10 minutes time. So we'll see you back here.
Good.
And we'll chat about what we've seen, some of the phenomena, some of the fascinating stuff that Lucy Green told us. And we are also actually going to replay. I hope you saw this, Bob. If you didn't, you're going to love it. The fabulous presentation. But you did, the Spire Legacy School. Those kids gave us our Eclipse 101. I'm sorry, Bob, but you are no longer my favorite Slooh astronomer. Those kids, all right, yeah, what a presentation they gave. I mean, I know that I'm out of a job, certainly. So anyway, Bob, we'll see you back very shortly.
Okay, good.
Now, I hope you enjoyed that. Trisha just was
Having a panic attack.
frantically, by my side while I was trying to hold back the tears, to show you that just awesome sight and try and share with you what it was like here. But anyway, deep breath. Trish shared with me the picture that some of the StarShare camera users got. Tell me about it, Trish.
It was more perfect than I think you could possibly have wanted to get. You know, we managed to get just hit that button at just the right time, just the right everything. It was really beautiful. Our technical director, my associate producer Ryan, who is actually running this show and doing an amazing job at doing it, actually said to me, "Wow, that is beautiful." And he's just watching on a screen, so I imagine everyone at home is also seeing these amazing views. I got to see a little bit of it after I had my small panic attack, trying to make sure our telescope looked good. And I'm really glad that we were able to get it.
Trish, well done. I mean, the amount of pressure that was on Trish just in that, you know, tiny minute and 47 seconds. You would not believe. I kept getting a
That
tap.
was a minute 47
a tap on my arm. Yes, it was only a minute and 47, not an hour and 47 minutes.
It felt simultaneously like an hour and 5 seconds.
Well, yeah, it did. It did. Now, yeah, Trish has mentioned Ryan Little back in the Slooh studio, and of course Slooh founder Mike Pellucci is back there as well watching. Mike, I hope you're enjoying this event as much as we are and viewers are. There it is. There is that frankly wonderful.
That's from our StarShare camera.
That is one of the best eclipse images I've ever seen, and that was from our StarShare camera. Thank you very much, Trish. But anyway, there's a huge number. Well, there's not a huge number actually. There's a very small number of people behind Slooh. We are incredibly passionate. We keep saying it, but you can tell. You know, I'm a grown man, for God's sake. You know, and I'm wiping my eyes just because the moon has gone in front of the sun. What's that about? You know, listen. I tell you, if you're in the USA next year, experience it for yourself. And if you don't cry like a baby, I don't think you're a true man. Trish, you didn't cry. I'm very upset at that, actually.
I guess I'm not a true man.
Okay, well, there is that, of course. I'm glad we proved that once and for all. We are a small team. We're passionate about what we do, but we need your support to do it. We really need your support to do this. It's not easy, as you can see. The other team here, their broadcast is for 10 minutes. We do this. We bring you the full eclipse from the beginning of the partial phase all the way through to totality and all the way through now until the moon leaves the sun altogether. We need your support. The way to do that, the way to support us, if you enjoy what we do, if you share our mission to share our night sky that we all should be sharing, join Slooh. You'll have great fun. Yeah, you'll have great fun. We are going to see a short video now, and we are then going to get Bob back.
Yes.
Yeah, so we've got Bob coming back, and it's going to be Trisha, Bob, and I. We're going to be riffing on some of the things we've looked at already, going over a few other things. I hope to see you in the Slooh Clubhouse, which is where members hang out when they're controlling the telescopes and taking their images. Anybody can always contact me. We're an open crowd here at Slooh. Just email me at paul@slooh.com, and we'll be a bit busy over the next couple of days. We've got to get back. We've got to pack all this gear up and get back. But in the meantime, we are still going to enjoy these wonderful video images and the StarShare images as well of the partial phases. Here we've got this gorgeous crescent of the sun. So what we've got there is that yellow part, that's the sun just reappearing from behind the moon as the moon's shadow. Now it raced up behind us at 1,000 miles an hour from the west. It is now heading out into the Pacific Ocean, where places like Hawaii are going to get a partial eclipse, and we hope to be able to bring you that after this show. So keep an eye at slooh.com on the page where our live shows play, and we should have, if they've got clear skies there, we will have another feed showing you the partial phase from Hawaii. You can hang out on that page, and as Trish said, use chat in there, talk to other members, stuff like that. But join. We need you to join. We're going to be back after this little short video.
Good Lord, ride all the way. -40. Status check, pressurization. Locks tanking.
The chakras are connected to the solar system. Mercury, Earth, Pluto, which is not a planet anymore, Venus, Jupiter, and Mars.
Most people really don't look up and don't realize that there is a whole universe that is above their head.
Absolutely amazing. And there's the diamond ring.
Space, it's an inspirational place because you're seeing new things.
There's this one star, and it just moves. I don't know why.
I quite like Orion, I like what the symbolism.
UFO about half a mile from your position.
The whole world pouring by outside your window, and the joy of weightlessness.
7, 6.
5, 4.
There's no way it's just only us.
3.
It's Mars.
2.
Beam me up, Scotty.
1.
Blast off!
Space is so vast, the question to be asked is, what are the chances of not finding life?
I think astronomy can put things into perspective for people, make us realize that we're all part of something much bigger than ourselves.
Hello, and we are back. You are back. Actually, Trisha's going to get up, and she's just going to put us on the straight and level. Can you?
I can do that.
Could you do that?
I think I can do that. I took a really great picture, so I can do that.
I feel like I'm about to fall off my chair.
That's because I turned the tripod.
Now we have got a live interview coming up, but with Dr. Miguel Sierra Ricar. He's director of Shelios and the IAC about the expedition, and he's been talking to all this group of students that you've seen behind us throughout the show. But for the moment, we're going to get Bob Berman back in because Bob, now I've settled down a little bit now. Can you hear me?
I can hear you loud and clear. Yes.
So, hey, Bob, I mean, that was an experience to savor. I mean, I think I suddenly saw, I knew this was going to happen because I got some star charts together over the last couple of days to say to the team here and everybody else here, we're going to see Venus, we're going to see Mercury probably, and there was even a slim chance, we'll have to check the images later, that we may have seen Neptune as well in the photos. That would have been too dim, too faint to see that with the naked eye, but that was the first thing that kind of caught my attention. And I think, Bob, you know, to kind of start off talking about this, the thing that surprised me there was actually when totality started, I was a little bit underwhelmed. I thought, are my eyes a bit fuzzy through lack of sleep? Because I couldn't really see any detail, but then suddenly, and you said it at the time, suddenly we saw those bright, beautiful, it's a kind of purpley pink prominences, you know, coming from the sun. I mean, it was, and then I realized actually that totality itself has its own phases. Is that what you've experienced in the past?
Yes, quite so. And one of the things that do vary astonishingly is the shape of the sun's atmosphere or corona. This one had a configuration unlike any I've seen. They're all unique. Of course, they go with the sunspot cycle. We are now well into cycle number 24. And depending upon whether the sun is being wimpy in its output or whether it's strong, you can either get a very symmetrical, interesting, round corona surrounding the sun, or you may get much more activity streaming from some parts of the sun, for example, from the poles, and then the rest of it just have lighter streams. But as you looked more closely and changed the exposure, notice that you saw delicate tendrils of solar plasma, that is, broken bits of atoms, that were faithfully following the sun's very strong magnetic field. And to reveal the sun's magnetism, I mean, what's magnetism? Most of us think of it as something you'd put on a refrigerator to keep your notes of what you're going to do that day. But this is a powerful, influential, not just in how the sun appears, but in how it affects us and what kind of activity there is and whether cosmic rays from beyond the solar system are blocked. So what we're seeing is just the visual hint at much deeper and more powerful forces at play. And you don't really see it unless you see it, unless it occurs. But there it was with this corona. It was just beautiful. And then within it, the inner corona with those hot pink individual prominences.
Yeah.
Did they look hot pink to you, Paul?
They did. I mean, it was a stunning color, and it was only at that point that I realized, right, that's what totality is about. But you were talking about the corona, and it's a little bit, isn't it, Bob? What you've been describing there about the sun's magnetosphere and sculpting those hot particles in the corona. It's a bit like that iron filings trick we did, didn't we? Back in school, where we got a magnet on a piece of card, put iron filings over the top of it, and that's really what we're replicating, what we're replicating what the sun does, I guess.
Of course, but on a huge scale, because the sun has temperatures approaching 4 million degrees in this. A puzzle for a long time, Paul, because the sun's surface is only 11,000 degrees Fahrenheit, closer to 6,000 degrees Celsius, but 11,000 degrees Fahrenheit. So how the heck do you go from this relatively cool surface of the sun, even though it looks blindingly bright? How do you go from that to 4 million degrees? What's the mechanism for heating that sun up so that you can see a corona stretching around the sun that's whose temperatures are beyond belief? And it turns out the secret there too was magnetism, and especially the magnetic field lines snap. And this isn't just playing with the little magnet, and now you're moving the two magnets apart too much, and now one can't pull on the other the way it used to. No, this is a giant disconnection. So the connections and disconnections cause unimaginable forces and powers on the sun. It's magnetism all over again in a lot of different ways. Even the sunspots on the sun are places where the magnetism is 5,000 times greater than just in the surrounding parts of the sun. So to see this, not just read about it in a textbook, but to see it with your own eyes and see it changing. And to me, again, it's the celestial mechanics, the motion of it, because on Earth, where you are, you're spinning about as fast as Earth can spin, which is 1,038 miles an hour at the equator. The moon moves 2,289. Not too different a figure. And here's one hitting the other. And so what's the result? There it is, the sun leaping, having its shadow stretching across the ground, and also giving the lie to something that you'll often hear, Paul. And I know you've read and heard people say during an eclipse, you can see the shadow of the moon approaching. Look off in the direction of the shadow is approaching. Look east, and you'll actually see the shadow approaching along the ground. Well, not really, because the shadow has a great thickness to it. Because at one point the shadow is 99.999% blocked. Another 40 miles is 99.998% blocked, 9.7. And so there's different levels of brightness on the ground. And that's what you see approaching if you have a vast, distant vista. All you're seeing are levels of brightness of the sunlight hitting the Earth. There's no one perfect cutoff where you're going from full sun or even most sun, not even 70% sun, to no sunlight. And then I'd say a final surprise for people starting out with eclipses is how not dark it is. People are expecting, complete darkness. But
Yes.
if you want real darkness, just don't pay your electric bill, or lock yourself in a closet. Darkness isn't the people imagine that they want to see darkness, but that's so wrong. You close your eyes and you can get darkness. No, what you're getting here during totality, as you saw, it was every bit as bright all around you as the light of a full moon. You could easily read by the light from the totality. So that again is not the issue.
Yeah, it surprised me, Bob. Actually, it was two surprises there that you talked about. One was that I didn't really notice the darkening coming from the west, but also the level of darkness, as you say. I was surprised. It was more like twilight. Bob, we are going to have you. Actually, we've got a question first of all from one of our viewers. Trisha's going to ask that for you.
Hi, Bob. We actually, you might know this, but you have kind of a fan club among Slooh members and
Yay!
Slooh viewers. People absolutely love all your encyclopedic knowledge of space, and they love your voice. And we have actually one person who asked, can you narrate the eclipse of the century on the Viking Serenade on July 11th, 1991?
Yes, I did.
They were there, apparently. And they remember.
They were there. Yes, I narrated that one. And I had the foresight, the wisdom, the blessing to also stay silent during the total part of the eclipse. Just as I noticed Paul and Trish were about as perfect hosts as you could be. There was totality. They properly raved and ranted. They couldn't help themselves. This is involuntary behavior. But they did not spend their time saying, oh, and there is the this, and there is the that, and notice the this, and here's the that. Well, we got the introductions to it. This was the time to be almost in a state of meditation. Get into your full lotus position. Look up at, light some incense, and take in one of the great experiences of your lives. I think most of the people who are there will agree that now that you've seen one, especially if this is your first, you'll find that they are addictive. You have to go no matter what cost, even if it means selling the house, selling the children for animal experiments, whatever it takes.
Children, yeah.
You've got to find when will the moon shadow again touch Earth, and how can I get there? Because that's how addictive it is.
And Bob, later on in the show, I am going to be calling on your superb encyclopedic knowledge of such things when we tell viewers how they can experience probably what is going to be the most widely seen total solar eclipse. Well, maybe, I don't know, maybe in recorded history, if you think about the population area, the Great Eclipse of the USA 2017. So we're going to ask you, be prepared to
I think you're exactly right about that. Precisely right about that. And I'll be glad to talk about that.
So, Trish, we haven't actually properly asked you what reaction you had to that event. Was it a little bit like me that we are so engrossed in the work that we have to do, especially at such a critical point? Do you kind of feel like you missed out on the event yourself? Are you looking forward to seeing the show later?
I am looking forward to sleeping later, but I think I will watch the show maybe a little bit after that. Yeah, I would agree with you that you're engrossed in doing the work, so you sort of miss just being able to sit here and watch.
Yeah.
So especially people in America next year, if you live in America, if you're able to get there, go out and watch it for yourself. I was able to, in the midst of my panic, once I knew I'd gotten what I needed to get, I was able to look up for just a split second, and it was still amazing and awe-inspiring, and just it's difficult to describe exactly like what it looks like and how it feels, and it does get very eerie.
Well, you were nervous, weren't you,
terrified.
about grabbing this moment, and you had 1 minute 47 seconds. Now in Kenya, when we were in Kenya, amidst all of the problems and the dust, no, we had 12 seconds.
12 seconds.
We had 12 seconds of totality. Bob, what's the normal period of totality that people can expect to see at an eclipse, and does it vary depending upon where you are? We're talking about
amazingly. The longest one of the century was over 7 minutes, and then we've had 6 minutes and 22 seconds. We're going to have another eclipse that's going to be close to 6 minutes 20 seconds. That's going to be a 1927 in Egypt. And then they're going to get shorter and shorter after that. As for the shortest eclipses, the average is probably around 3 minutes. So a 2-minute eclipse, such as what you've just seen, is not bad. The one that we're going to have in the United States at almost 2.5 minutes is quite nice. Probably the most famous. There are eclipses for 1 second, and I know a group of people who chartered a plane for the 1 second Post-totality.
Wow.
Back about 20 years ago, and perhaps the most memorable long one, over 7 minutes, almost 7 minutes 20 seconds, happened on July 10th of 1991, and on that date in Baja, Mexico, the eclipse was so long that people were opening up paperback books and taking naps, putting on, setting their alarms. Wake me when it gets to the last minute of totality. I'm making this up. This crazy stuff. I'm sorry. Stupid joke. It's not. It's never. It's never that long that you get restless. That you have time to get restless. But yeah, you can get over 7 minutes though. That will not happen again for the rest of this century.
Well, let's when we come back talk more about give viewers some guidance on next year's USA eclipse. Now we are going to take a short commercial break. Bob, we'll see you back in 5 or 10 minutes. So we're going to take that break. But after that, we are going to be talking to Helios expedition leader, Dr. Miguel Serra Ricard, who is also the manager of the Institute of Astrophysics in the Canary Islands, home to Slooh's flagship observatory and telescopes, the telescopes that members can control every night. So we will see you with that interview immediately after this commercial break. Live coverage of the total solar eclipse in Indonesia. We have been having a fairly marvelous time of it here, and I am joined by Helios expedition leader, Dr. Miguel Serra Ricard, who is also the observatory manager at the Astrophysics Institute in the Canary Islands. Miguel, this is your 13th eclipse.
Yeah.
It was a lucky one, wasn't it?
Yes, after 3 years, because we have Australia good in 2012, but Kenya, we have a dust storm. After Kenya, we have Faroe Island, nothing, and here, at the end, wow, it's incredible because the weather is fantastic, transparent, fantastic transparency. Okay, so it's a very good eclipse.
What were the highlights of totality for you? It was pretty amazing when we saw the prominences. Maybe after 30 seconds they appeared.
To me, I have a problem because I forget to remove the filter.
Oh.
Yeah, and I don't see the corona in my telescope. No. Yeah, and I say no, the exposure time, no, it's not pointing. Yeah. But then it's the filter. Okay.
Oh.
So after 10 seconds, I fix the corona in the telescope. After that, I look to the corona. Incredible. Wow. It's incredible. It's symmetrical. Yeah. It's changing. It's not as symmetrical as in Australia. Yeah. But to me, the more exciting thing is the first time that I see the interference bands in the building.
Okay. Now explain explain what these were.
Yeah, in the 2 or 3 contact, only a very narrow beam of sun goes to the atmosphere. Okay, and this produces interference band moving due to the atmosphere. So this is possible to see if you have some white surface.
Okay,
so
okay. So the building was
perfect. The building was perfect, but it's in your back, so you don't
didn't see it.
Yeah, you cannot see it.
Now,
but
I had read about those, but that's not very common because
it's not
the conditions have to be perfect. Yeah?
Yes, in fact, but it's perfect also in the ground.
Yeah.
But it is better to see in the building, in the wall. Incredible, oscillating the band.
Now, you like us had very little sleep last night.
Yes.
We woke up and we saw cloud across here. No stars. Yes, by the time you came, I came and got you, and I was excited. I said, Miguel, come and see
Venus.
And Venus was so low. it told us
Yeah.
that there were no clouds there.
Yeah.
So where does this is your 13th eclipse, where does this rank in, or is it possible, is it like children, if you cannot have a favorite child?
No, this is one of the best probably, because let's see, the best one was in Russia, Novosibirsk, 2008. Okay, very transparent. But this one probably is the second one, because we have not Sirius. The transparency is good, because in China, in the ninth, and also in Australia, we have some clouds, some Sirius. Not
And
here,
you lose
nothing.
the corona with even a small
Lose
amount
the
of
details of the corona.
See.
By the naked eye, it's possible to see today or tonight during the night a very detailed the details of the corona. So it's a very good eclipse. Yeah.
Well, it looks like you enjoyed it as much as we do, and you've just been giving an impromptu talk to all of the university staff here, and they enjoyed it. You have a new fan club.
Yes, at the end, my broadcast, was also in English, but it's a very funny English, because I try to explain. It's important to outreach in this
Talk about that.
broadcasting.
Tell us why you do this, because you do it because you love seeing the eclipse yourself, but you also do it like us because you want to share this phenomenon with everybody.
Yeah, but with children, with the students.
With children
This
and
is the
students.
more important thing to do in our world. Motivate the students to change this world, because the only possibility is to loving this kind of events and try to understand why the eclipse happens. And this is my main motivation, this broadcast, because at the end I cannot do science. It's impossible. I am speaking in Spanish easy, in English I must sing, and also I control the telescope. And but very happy here, the people, and help. This university, these people help us a lot.
We've been saying it throughout the show. I mean, the hospitality they've given us, they shut down the whole campus network, so we have the bandwidth for our broadcast. It's been amazing hospitality. Now, before I let you go, we like to ask all of our guests what inspired them to get interested in science or astronomy or technology. Some people say it was the teacher, some people it was parents, some people it was reading a book in the library. What was it that inspired you to get involved in astronomy and science?
It's a very complicated question. Maybe is to read some book, and also to participate in these kinds of activities.
So it was people sharing this with you.
Yes.
But maybe so you have been responsible. Behind us here, viewers, we've got a collection of maybe 30 people here.
Yes.
And they're all youngsters, they're maybe 25 and below.
Yeah.
And you have probably inspired a whole new group of astronomers like yourself.
Yes.
So you've succeeded in your mission today.
I completely agree with you. Probably these people here, never in their life, forget this experience. So probably speak well about physics, about astronomy. This is very important.
And speaking well of people like you, astronomers who take the time to share their love of what they're doing with them.
Yeah,
it's very generous. And on that note, you're also very generous to us. Shelios, you manage that and you do all of the logistics of these trips. It's fantastic.
And also want to speak about this is supported also for an European project.
Yes.
Stars for All.
Stars for All
is a age 2020 project, and is related. The goal of this project is to try to create a collective awareness platform against light pollution. So this is very important for us.
And this is to our heart, because Slooh's mission is to share the night sky. And you can't share the night sky if you have light pollution. I don't know if you noticed, but I noticed after totality, but the lights the street lights
No,
over here had all come on.
I only
you
see
know?
the interference
Yeah,
bands.
yeah, okay. On
No.
that note, the scientist is going to leave us. Miguel, thank you
you
so much for joining us today.
Thank you very
on
much.
Slooh
Thank
Show.
you.
Thank you, Miguel.
Bye bye.
Well, he's always an inspiration to talk to. I've known Miguel now for 12 years, actually, since Slooh have been operating their flagship observatory at the facility which Dr. Miguel Sierra Ricart actually manages in the Canary Islands. And that is where the huge Slooh telescopes, half-meter telescope, and that's big, I'll tell you, a half-meter telescope is a very large telescope. They are there and they can be controlled every night and are controlled by Slooh members. So if you've been a little bit inspired by what we've been doing today, or maybe by somebody like Miguel who shares his expertise and passion for the subject, then maybe drop along to Slooh and join us today. Join us today, join in the fun, and control some wonderful telescopes. And if you enjoy this kind of event, which I'm going to shade up, Trish.
You're gonna shade
I'm going
up?
to shade up.
You gotta use the hashtag.
Oh, sorry. I'm going to hashtag shade up.
Hashtag shade
All right.
up.
And I am looking still at this huge chunk of the solar disk, which is still being eaten by the moon. And we can see it in our live images that Trish has been keeping going here, this live video stream. Trish, did we have some other feeds? I mean, we weren't able to see these, but we had some other feeds, didn't we, during
Yeah,
that?
we had a few other feeds coming into the system and into our studio and into our StarShare camera, and I know some people were able to snap some photos of those other feeds as well as ours at Totality.
Great.
And you know, there were some really great
Were they
photos.
as good as yours?
I'm gonna say no, but
Okay.
I'm a little biased.
Okay.
A little
Okay.
bit.
I'll measure it. I'll measure it tonight. Staff appraisal tonight. Is that
Staff
okay?
appraisal. Okay.
Yeah?
Yes, I think
Yeah?
that'll be good.
Or will we just be fast asleep?
I don't know. I'm a little wired right now. But no, we had some great feeds. We had one from a feed partner who's actually in Palu at a different
Justin
location.
NG.
Justin
Yeah,
NG,
he's a
yep.
professional photographer. He has a tour group.
He takes some amazing photos. I was looking
taken.
at his website.
Brilliant.
He took some
Yeah.
amazing photos today, and they were very sharp images and just some really great photos.
We will share some of those on Slooh later on. Actually, we'll pick out some of the best of Justin's images as well. Now, remind people, we obviously have not got the end of the eclipse yet. We're still underway.
No, we still have quite a lot of eclipse left to go, actually.
But after our show, we're hopefully going to be getting the partial eclipse, a feed from the partial eclipse in Hawaii, right?
Yes, yeah, we're hoping for it. They were having some poor weather earlier today. It's not quite as cloudy as they expected it, but it's still cloudy on the mountaintop. So we'll see if those clouds clear up and if they're able to get a good shot of the partial eclipse. But it's actually quite a while after ours. Hawaii is quite a ways away.
Yeah, yeah.
I always forget how far Hawaii really is from everything.
Across the Pacific, and that is where the moon shadow is racing at the moment, across the Pacific. So now we are going to go to a very short commercial break, but you have got to stay. You have got to
My
stay.
favorite segment I think we've ever done.
Yeah, I think it is. Yeah, me too. We did another presentation actually at a school, or the school kids did a presentation last year, and that was fun. But this one, after the commercial break, you are going to see a repeat of the awesome Eclipse 101 that the students at the Spire Legacy School recorded for us. If you missed it during the first half of the show, you must not miss this. This is probably is the second moment of this event not to miss. Totality.
And these kids are third graders, and they're amazingly smart, and it's really fun to watch these kids really get excited about an eclipse.
And for ignorant people like me, how old are third graders?
8 years old.
8 years old. Okay. So I was away during my child's upbringing, so I don't know these things. Anyway, we are going to cut to this commercial break, but do not go away because we are going to stay here with our partial eclipse views, and we have Bob Berman coming back as well. And
everyone's favorite.
Please ask us some questions. Bob, I challenge you actually. I challenge you to find a question about solar eclipses that Bob Berman, Slooh astronomer extraordinaire, cannot answer with his encyclopedic knowledge. So we will be right back after the commercial break and the Spire School Eclipse 101.
Yes.
Welcome to the Spire Legacy School in New York City. The third grade has been studying the solar system and learning about solar eclipses. What is a total solar eclipse? How often do they occur? Why did Slooh have to go all the way to Indonesia to see it? Why is it a total solar eclipse in Indonesia but only a partial solar eclipse in Hawaii?
Total solar eclipse is a cool mistake in nature.
It's when the moon gets between the Earth and the sun and the moon casts a shadow on the Earth. A solar eclipse can only happen at the phase of a new moon when the moon falls directly between the sun and the Earth, which makes an alignment.
The darkest part of the shadow, or the umbra, is almost as dark as night.
A place in which the shadow goes pitch black even in the middle of the day. Did you know that during a solar eclipse, the moon actually casts two shadows towards the Earth? One shadow is called the umbra, which becomes smaller as it reaches the Earth.
The second shadow is called the penumbra, which becomes larger as it reaches the Earth.
A total solar eclipse occurs approximately every 18 months. We had one in Kenya, November 2013.
One happened in March 2015 in the Faroe Islands.
Right now, one is happening in Indonesia. They don't occur very often because the orbit of the moon around the Earth is not in the same line as the equator. The orbit is at a tilt, so it only lines up with the sun once in a while.
Slooh had to go to Indonesia to witness the total solar eclipse this year.
They brought a lot of equipment with them to Indonesia.
They also have live streaming ginormous telescope in Indonesia and other places on Earth.
Because of the way the Earth is facing the moon and the sun, the umbra is only going to hit a certain spot on the Earth. For this eclipse, it is Indonesia and parts of the Pacific. The reason why there can be a total eclipse in Indonesia and a partial solar eclipse in Hawaii is because Indonesia is where the moon's shadow will fall.
The shadow or the umbra is actually very small compared to the moon.
The umbra is a very dark shadow.
For this eclipse, Indonesia lines up with the sun and the moon.
And the umbra will cast the land in the path of the eclipse into darkness.
Hawaii is not completely lined up with the sun and the moon, but it's not too far away from Indonesia. Only part of the moon's shadow will fall on Hawaii. In the rest of the world, either nothing happens or a partial solar eclipse occurs.
But if you want to witness it from New York, you won't be able to see the eclipse even a little bit because our part of the Earth won't be facing towards the alignment of the sun and the moon.
Thank you for joining us. Keep watching the eclipse and keep your eyes on the sky.
Hello and welcome back. You're watching Slooh at slooh.com for the total solar eclipse of the sun in Indonesia. We've seen totality, but we are still here and we are going to stay with you right up until that last little nip of the moon disappears from the sun. We are welcoming back Slooh astronomer Bob Berman. Now, this is your opportunity to ask us some questions about eclipses or anything else. You want to know anything about Slooh, you want to know anything about eclipses. We are going to do a little bit later on with Bob, and we are going to talk specifically to Bob, get the gen from Bob, our expert, on where to see, where to view the USA 2017 eclipse. And Bob, on that note, I mean, your book, The Sun's Heartbeat, is a marvelously entertaining as well as informative read, and anybody who's enjoyed the coverage today would really enjoy a copy of that for their birthday or Christmas. But you've got this wealth of experience when it comes to eclipses. How many have you seen in your lifetime? If that doesn't give away anything.
I've been lucky to see 9 so far. And before I go on, somebody just pointed out that when I talked about upcoming long eclipses, the one that stands out is the 6-minute 22-second total eclipse in Egypt. I said in 1927. Of course, an upcoming eclipse cannot be 1927 unless we get in a time machine and go back in time. It's 2027. 2027.
The heat at the moment,
Actually,
Bob.
August
The
2nd
heat
on
of it.
that date. But we will have one in America. We'll have actually several in America before that, including the longest eclipse in U.S. history, even since before the American Revolution. That is, we too will have an eclipse over 6 minutes, and that'll be on August 12th of 2045. That'll be the same night as the meteor shower.
I feel like we need to admit that American history is not entirely very long compared to other history.
True. It's absolutely true. And we have, despite these few centuries, Trish, we have a lot of legend that got crammed into them. We have had eclipses where Mark Twain was obsessed with seeing them. We had a great one where well, that one on January 24th, 1925, that I think it was Lucy Green mentioned earlier, that was the source. She said the source of the term diamond Bailey's beads came from a British astronomer a little earlier, but the source of diamond ring, that came from a New York City reporter during the total solar eclipse in New York City on January 24th, 1925. And on that eclipse, the line was so fine between where the sun would be shining and it would be daytime and where it would be nighttime that people volunteered. Boy, I take my hat off to them because I wouldn't volunteer for this. They raised their hand and they said, yes, I'm willing to stand on this street corner or this one or this one. And so you had observers on every single street from East 79th Street, East 80th, East 81st, East 82nd. And it turned out south of East 86th Street, it was daytime. And north of it, it was, and into the Bronx and on up north to Woodstock and Albany, it was night. It was a total solar eclipse. And so we knew exactly where the edge of the sun was because of that eclipse. And it was then that a reporter thought that that last bit of beautiful sunlight shining through some final deep lunar valley produced the effect called the diamond ring that we've been using ever since, that term.
Ah, okay. And we saw, I mean, that was the absolutely best diamond ring image I think I've ever seen, that Slooh, users or people watching at slooh.com were using the StarShare camera and snapping and sharing that image. Trish, you got something?
I actually do. I have a question for you, Paul, actually.
Okay.
We have a lot of questions coming in for Bob, so we'll get back to him in a second. But I wanted to ask you, now this is the second eclipse that I've experienced with Slooh. I actually watched your eclipse from the Faroe Islands last year. It's how I got the job.
Absolutely.
It is. And this year I get to actually be here. So what other eclipses have Slooh members been able to experience?
Well, over the last couple of years, the two notable ones are the Kenya expedition. That was in 2013.
13?
Okay, sorry, I'm not good with dates and numbers.
Even when you were there.
Not all, not everybody in us who's interested in astronomy needs to be interested or good at numbers.
Good at numbers.
So, but the Kenya, that Kenya was challenging in such a way just because we were out in the middle of nowhere. We actually went to the cradle of mankind for that eclipse, which is off Lake Turkana in Kenya, and it was so challenging. I mean, you've now experienced what we have to do just to get here, let alone all of the work that's actually required here. I mean, I hope that surprised you, has that?
Yeah, it did surprise me, and it didn't at the same time. I think you well prepared me for the amount of work we'd be doing.
So I did that. So, it is grueling. It's certainly made up for it today. I mean, to have clear weather and to be able to share that with everybody.
And suddenly clear weather too.
Absolutely. We were totally clouded out earlier on. But so we had the Kenya eclipse. Now that one we were clouded out on, but we actually had a dust storm. We had set up all the equipment, but would you believe we arrived only 5 hours before the eclipse was due to start at our campsite?
Oh.
We'd never seen the campsite. We hadn't even unpacked our equipment, and we had to go from nothing to setting everything up, getting ready in 5 hours. But then, just as the eclipse started, just as our live broadcast started, the dust storm came in, and and it was hilarious in some ways because the rest of the team members, while I was broadcasting live, Bob, I think you can remember this, they were holding on to the big covers and big tents, because they were being blown away. The second recent eclipse that we covered is the one in the Faroe Islands, and that was 2015. And we were challenged again by the weather there. And the challenge was slightly different there, that we were totally clouded out beforehand, so we couldn't do any preparation for that whatsoever. Hey, look at this live feed, Bob. Oh, no, that was actually,
that's Kenya.
that was a bit of Kenya, and that is the
I
moment
remember
of
that. Yep.
totality.
And
My goodness, that was
and
that
you
was an
you still flipped out. You still went crazy, even with the mostly cloudy skies. So, I was so hoping for you to have clear skies this time. I'm really, if I had to vote for your next eclipse to be clear for you or mine to be clear for me, I would have chosen you. So I'm really glad.
Oh, that's very, very generous. I think actually this is a live. Is that a live shot that we've got there?
No,
We'll
right
find
now,
out.
actually, we have a live shot in the corner on the right-hand side of the screen. That's our live view from our telescope here. And in the main pane, we're actually looking at some of our best eclipse coverage that we've done for the past several years.
So anyway, I was talking about the Faroe Islands. That was a totally different kettle of fish because we had bad weather. We had cloudy weather all the way up to 2 hours before we started.
Wow.
We had to set up our equipment inside in anticipation of going out. And we did get clear skies, but we really didn't get very good images of it at the end. I mean, it was
No, but I think
I'm wrong.
travails. I think your travails are coming to an end. All the odds are now turning around the other way. We've suffered for a long time now. The last eclipse anywhere in the mainland United States was at the end of February in 1979. Trying to remember if it was February 21st or 29th. You'd think I'd remember these things. That was the final U.S. totality, and we knew back then that it was going to be 38 years before the moon shadow would touch any part of the mainland United States again, and yet, look at us. We're 1 year from that date now. 1 year,
1 year
from
away.
the long-awaited total eclipse in the United States.
Now, Bob, we are going to talk a little. We're going to talk a little bit later about that, but I think we've got some questions from viewers for you. Trish's going to ask these.
We do. I need to grab my list of questions here. We have a couple. So we have one person who asks, why did the diamond ring occur at the specific place on the circumference of the moon's shadow?
Oh, simply because as the moon is covering or uncovering the sun, there's always going to be one section of the moon's profile that's has a dip in it. The moon, remember, is 2,160 miles in diameter. It's only 4 miles out of round, and some of its craters or dips are several miles deep. So that all we need is, as the moon proceeds to cover the sun, you need one last deep spot to still let some sunlight in straight through to our eyes while the rest of the moon has blocked it. And more often than not, that happens. And so we get that beautiful diamond ring, which is more beautiful than can be seen in images. Now, I'm the last person who will disparage what we just saw because none of our viewers are able to see this without you guys being there and having actually journeyed to that part of the world. But the truth is, now that you've actually been there in person, just like falling in love or swimming in warm tropical water, there are some experiences that are one thing to experience them directly, and quite another to take a photograph, no matter how good the video or the photograph is. And in the case of a total eclipse, the actual visual experience, I don't know, something happens when the sun and the moon and your spot on Earth form a straight line in space. That's why animals go crazy and people weep like Paul did. Sure, there's an intellectual and scientific component. Certainly, there's been long preparation and there's a certain relief of having finally seen it. But would you not say, Paul, that there's also a component that's visceral and experiential and quite transcends the merely intellectual?
Oh, absolutely, absolutely. I mean, it's totally consuming. I can't imagine actually what it's like when you're not actually working, at an eclipse or during an eclipse, as we are. We're totally focused on trying to get our viewers the best information, the best live streams. So, but one thing that you said there, Bob, and as great as that image was of the diamond ring that I saw some members or some viewers had captured using the StarShare camera, as great as that was, that was one part actually. That it was the second diamond ring. So it was when totality ended. That surprised me because I was looking at the sun then, and it wasn't white. It was almost silver. It was the most
Yes, quite
brilliantly
so.
sharp.
Now,
It
here's
was the
one
most
more
brilliantly
thing.
sharp.
Listen, Trish and Paul, confirm this.
Mhm.
When we use our equipment or anybody uses equipment to capture it and the diamond ring appears, it is so much brighter than the rest of the sun. Certainly the eclipse sun, the
Yes.
corona, the other parts, it is so much more brilliant that to get any kind of exposure at all that doesn't look washed out and just beat up and blurry and stuff, we have to shut down the aperture in a way that allows it to be visualized at all. And the process by doing that produces a larger image, a larger diamond ring than the actual event itself shows or that the eye shows. What I'm saying is that the actual diamond ring, when seen visually, is more powerful because it's a teensy weensy when it first appears, of course, a tiny, teensy, intensely luminous dot of light, very much like a small diamond whose one facet perhaps is casting brilliant light towards the observer's eye. And then the rest of the ring part of it is another story. You don't see that in the photographs. In the photographs, what you see is a larger looking blur of the diamond ring and not that crisply sharp silver image. So that's one of
Yeah.
the images that I'd say are you got to see it in person. Another is one I deliberately didn't mention because it can't be photographed, and that is the shadow bands. I noticed that your mentor, your observer there, um, said you saw them. You don't see them in every eclipse, but these are like the wiggly lines you'd see at the bottom of a swimming pool, a filled swimming pool. You know how there's those shimmering, dark, thin lines? You know what I'm talking about?
Unfortunately, Bob, those were behind us.
Yeah, they
So
were right
we
behind
didn't
us.
get to see that. Trish, you got other
Yeah,
questions?
Excellent.
actually, I don't have a question just this moment. We do have a lot more to get to, but I wanted to
Okay,
take
go
this
ahead.
moment
Go
because
ahead.
we're talking about the way that we react to and respond to eclipses and how they have sort of this stilling effect on a lot of places. We actually wanted to take a moment to go and one of our Slooh astronomers, Eric Edelman, actually has something he wants to share with us about the way that eclipses have actually affected people in ancient times and how one time they actually stopped a war. So we're going to go to Eric real quick and we'll be right back with Bob.
Excellent.
Hi everyone, I'm Eric Edelman from Down to Earth, and I'm here to bring this eclipse a little bit more down to earth. Not literally, of course, but isn't there something magnetic about an eclipse like this? Our sun is such a constant in our sky. We don't actually look at it unless achieving blindness is on the bucket list, but evidence of it being up there is everywhere in our lives. Even at night, we see the moon because it is reflecting light from the sun back at us. Then, all of a sudden, for a few minutes on a very specific day on a small chunk of the Earth, everything changes. The light vanishes and the sun is gone. We know why it happens. We know this is the moon passing in front of the sun. We've seen the man behind the curtain. We can even predict these eclipses years and years and years in advance now. We've got them, as they say, in the bag. Even so, they are still absolutely magical to witness. Talk to anybody who has seen a total solar eclipse, and they will tell you, and they will keep telling you and keep telling you. If it's amazing even knowing all that we know, just imagine what it would be like if you had no idea what was going on. Well, some historians say that an ancient eclipse was mind-boggling enough for some people that it actually ended a war. This eclipse is known as the Eclipse of Thales and occurred in approximately 585 BC, or so the story goes. About a century later, Herodotus, a Greek historian, wrote down the tale of this eclipse and about what a ruckus that it caused. There was a skirmish going on in Central Asia at the time between the Medes, or ancient Iranians, and Lydians, a group that resided around where modern Turkey is today. These two groups had been at war for years. Why? Well, one reason being fighting over some land, as people do. The other reason being that the Medes hired some hunters who didn't work out that well, and the king of the Medes ended up insulting these guys. In response, these hunters killed one of the king's sons, as is normally how things escalate when one is insulted, and they ran away to Lydia. The Medes asked the Lydians to give these guys back. The Lydians said no, and so it sort of turned into this US-Russia Edward Snowden sort of deal, except Snowden didn't kill anybody, and the United States and Russia didn't go to war over him. The Lydians and the Medes did. They fought and they fought for about half a decade until the Battle of Hales. Now, here is what Herodotus says about the battle in the history of Herodotus. Another combat took place in the 6th year, in the course of which, just as the battle was growing warm, day was on a sudden changed into night. The Medes and the Lydians, when they observed the change, ceased fighting and were alike anxious to have terms of peace agreed upon. Now, we can't be sure exactly what was going through the minds of these two peoples when this eclipse suddenly happened, but I like to think that it might have been similar to some rowdy kids who all of a sudden see the light flicking on and off above their heads and turn to see a disapproving parent flicking the light switch. Guys, cut it out. Time to stop. One incredible thing about this story is that just as we can very accurately predict future eclipses, we can also trace them back into the past because of what we know about the orbits of the sun and the moon and ourselves. NASA has a map that shows an eclipse that happened just about the time of this war and that would have occurred right around the place where the battle was being fought, near modern-day Turkey. This isn't proof that this story absolutely happened, though, as Herodotus said, but it does mean that it was very possible. I've been trying to think of a reasonable modern-day equivalent to this, some sort of image that could inspire in you or me the same sort of awe and terror that stops wars, or the equivalent for us of what this man feels when he sees a lizard on his shoulder. Same sort of thing. I thought it would be sort of like seeing a different color. And I'm not talking about you seeing green instead of blue or anything like that. Nothing that could be made from the primary colors or from your imagination of experiencing color up till now. A new color that all of a sudden covered the sky with no prior warning or explanation. Maybe, just maybe, that could end up stopping a few modern battles or two. Who knows? Let us know in the hashtag at Twitter if you have an idea of what could mystify us like eclipses did back in the day. At any rate, it's about time I got you back to the Slooh expedition team. Thanks for listening, and I'll be on later in the broadcast to talk about an eclipse that helped prove to us that Einstein's theories didn't just talk the talk, but that they could walk the walk too. See you in a bit.
Now that was absolutely fascinating, Eric. Thank you so much. I actually really love history, especially that kind of history where you sort of see how people reacted to things a long time ago that you, because of science and new understandings, don't react that way, and to sort of think like Eric actually asked at the end there, what kind of things are we baffled by now that maybe in 100 years, 200 years, 1,000 years, people won't be so baffled by, and they'll sort of laugh at us for starting a war over, one small infraction. Now, Bob, I actually had a question for you, and I'm wondering, are you surprised at all about that story?
I'm surprised. No, because I've heard it, of course, and I'm skeptical about it because it was written centuries after the account. And on one hand, of course, you guys just saw this eclipse. Are you going to start fighting each other? Pretend you're a married couple and something really is getting to both of you. And are you really gonna get into it during a total solar eclipse while this is happening? Of course not. It's gonna be the farthest thing from our minds. So I think that's a spectacle of nature. This amazing sure would stop people from the slightest impulse towards killing each other. So I believe that. But did it really happen? Did they really have no idea an eclipse was beginning? Could they see the partial phases, or is it apocryphal? And so I'd say maybe it did happen, maybe it didn't. If it did, it's a very lovely story. Even if it didn't, it's a lovely story.
I like to think that maybe it did happen. I mean, I'm you think about things like solar eclipses and these crazy things that the sun going dark, night in the middle of a day. I could see ancient peoples really thinking that maybe it was something that was bestowed on them by the gods. I mean, even philosophers and scientists essentially back then, had very specific beliefs and tried to conform what they were learning to those beliefs. And I could see it happening. I'm wondering if there's any phenomena that we find intriguing or frightening, or maybe something like alien abductions. One day we'll solve what those really are, and we will laugh at people who used to. I mean, we already kind of laugh at people who think they've been abducted, don't we?
No, you're probably right. Although they say that
Um,
if an alien craft lands and they invite you in, the standard advice is don't go in.
don't go in. All right, I'll
No.
try to take that advice. But aliens are very
Hey, listen, I stand on rooftops like this, waving my arms up in the air, saying, "Take me, take me."
Yes, exactly.
Okay.
That's me and Paul are. And as far as one of the other things I was curious about is, and Bob, you might know this because you have such an encyclopedic knowledge of just about everything. Is other than solar eclipses, can you think of other astronomical or natural phenomena that maybe affected people in a similar way?
Well, that's been a topic for me over the many years with not just Slooh, but many other publications. What are the number one, number two, number three, number four? What are the mind blowing, to use old hippie talk, events in the night sky? What are the things that are most yeah, astonishing that you'd go out of your way to see it again? You'd pay money to see it again. And after, leading, I don't know how many tours to how many countries, I've been overseas for 5 years now and watched people and asked them questions. I'd have to say that a total solar eclipse is the number one spectacle. This is the one that people come back to each time, that they find the sine qua non, the one without equal. So I can't say competing with that is such and such. But if there was something that might begin to compete with it, it could be perhaps a grand display, an unusually grand display of the aurora borealis. One of those that has unusually deep greens to them. Once in a while, you'll see reds as well, and you'll see motion. And those are no doubt spectacular as well. The problem there is they often go on for hours, and so the preciousness of the eclipse totality being only a few minutes kind of aids in its, how we prize things if we're going to assign value by the minute. The next object would be an exploding meteor or bolide. And these come without warning, but if you've ever been outdoors when a meteor blew up and a shower of sparks, absolutely everybody who observes it goes, "Oh my God!" And people ooh and ah and make sounds. Of course, now it's even shorter. Now we're talking about something that lasts only a few seconds, but that's up when it comes to great celestial experiences. And finally, among them would be what's called a great comet, one that is so bright that even through the light polluted skies that we have around more than half the world these days, that you could see the tail and the structure night after night, hugging at least 10 or 20 degrees of the sky. That means as long as, oh, let's say 2 or 3 or 4 clenched fists at arm's length, a great comet. On average, they occur every 15 to 20 years, and people who see them don't forget them either. So I'd say those are the major ones. Once you're using instrumentation such as the great Slooh telescopes, you're in a different league with colorful galaxies whose spiral arms are cobalt blue and whose centers look like campfire oranges, and the Orion Nebula where new baby stars are being born, and Saturn with its glorious rings, and all the other things that we're all so enraptured with. But naked eye, yes, let's call it number one, a solar eclipse, total solar, no other type, not a partial solar. Number two, the aurora borealis. And then after that, you have to really think about whether three should be assigned to an exploding meteor, or perhaps a total lunar eclipse, or a great comet. Then you'd have to start debating it.
I would certainly agree with you, Bob, on the 1 and 2. And if you remember, back we were talking about the Faroe Islands eclipse that we covered in 2015. Although Eclipse Day was fairly clouded out, what we had a few days before that from the expedition was we stopped off in Iceland. And if you remember, it was just at that time where there was a huge solar storm. And my first real view of the Northern Lights, I've been told by other people who were there, who have been watching them for 30 years, they said, don't bother going to see it again, because it will never, ever get better than that. And we had the most stunning live images of that. Yeah, it was a fabulous event. Now we must point out that this live image, this live stream from the telescope here by our side is still showing that little chunk of the moon covering the sun. It's more like a little nick at the moment. Now it's
Then
due
Paul,
to finish.
before you leave this topic, may I ask you a question, because you're one of the rare people then who could answer this survey. You've seen an extraordinary Northern Lights event. You have seen an extraordinary total solar eclipse. So you've seen them both now. How do you rank them? Which gets number one? Which gets number two?
Absolutely, by far, Bob. I mean, totality, and even though I've been working here, even though I saw quite a small amount of it with my naked eye, but by far. Having said that, there were slightly different events, as you said earlier on. This was almost meditative. It reaches into your soul, into your gut, whereas the Northern Lights was exciting. I can remember I was running in and out, from being on the show indoors on my laptop to outside because the camera was being controlled, and just seeing these spectacular images coming in, and being so excited. That wasn't a video feed, that was an image feed. Being so excited because I knew what viewers were about to see. So very different types of events. So I think for excitement, definitely the auroral display was just out of this world. But this one, yeah, just so spiritual, so spiritual.
I don't want to cut you guys off because this is actually a fascinating conversation, but we've got a little over 5 minutes left in the partial eclipse, and before we wrap things up, I really want to talk about next year's North American eclipse.
Yes.
Because I know that Bob probably has a lot to say about this. I am super excited about this. I don't have to fly halfway around the world to see it. I just have to drive halfway across the country. So,
yes,
I mean, do you have any questions? I'm curious where the best place to see it would be.
Yeah.
Well, this one is, I've been talking to Mike Palucci and trying to get him on board what we are already doing. He, of course, knows Anjali very well, who's the head now, president of our astronomy tour company. She'd love to bring you guys in on where we are going. Look at this map that you're showing. Not only do we have totality in America, but we have coast to coast totality. Unfortunately, the majority of Americans will think that Well, why should I get into that center path? Why not just stay home in Dallas or Phoenix or Minnesota, Minneapolis, where it will be a partial eclipse? Isn't a 90% partial eclipse 90% as good as a total eclipse? And as we all know, it's a
No.
rhetorical question. Not even close. No, not even close. You must get into that line of totality. Most people will not, but you should. Now, places are already
Yeah.
starting to book up. We've been researching this for years. Which sites are likely to be clear? Where is the eclipse going to be longest? Well, the longest part of the eclipse, and we're talking about 2.5 minutes or so, will be just around southern Illinois and Missouri. So we're looking at the sort of the right most third of the eclipse. However, you still get a full 2 minutes, which is nothing to sneeze at. If you went to the very middle of the eclipse, let's say to Nebraska or Wyoming or, those areas. So the question, the more important question is, where are you going to get heartbreak in the form of cloudy weather, and where are you likely to get
Yeah.
clear weather? Well, I'll ask you guys, and I think you can answer it yourself, including our viewers. If you're talking about August 21st, that is late summer, and you're talking about an eclipse that's going to happen around noon, well, on the left side, actually, the eclipse will be in the morning. As you travel along the path, it'll be more into the midday. And finally, on the lower right, when you get into South Carolina, it'll be mid-afternoon. Now, is mid-afternoon in the Carolinas a time that's likely to be clear, or is it hazy and puffy cumulus clouds forming there in August, every August at that time of year? And the answer is yes, usually. It's more likely to be cloudy there. That's not to say that if you don't have a home, if you already live right there, and in Lebanon, Tennessee, and all you have to do is leave your front, your back door and set up a lawn chair, that you should move anywhere. No, that would be awfully tempting. But if you're going to travel, no, I'd avoid the southeast for that reason. I'd avoid the Pacific Northwest for reasons that nobody has to explain to you. And so that leaves the driest section, which is the middle section of that map. So once you get into eastern Idaho to, let's say, Jackson, and once you're there near the Grand Tetons, especially just south of there in Jackson, Wyoming, that's a very clear time. We've done a little bit more research than that and looked at the effect of mountains on the cloud formation. And we and a number of other groups have decided, professional groups, astronomer groups, have concluded that we think the best area is going to be around Casper, Wyoming, just because it's more immune to mountain wave at that time.
Well, Casper, Wyoming, we got that, but we are on our countdown to fourth contact, the official end of the eclipse, 765. I'm actually going to look at that with my glasses while viewers can still see that. Now, I can't see anything discernible now.
It should be over.
So I think that was it, Bob. That was the official end of our eclipse. We're going to be hanging around for a couple of minutes. So please finish off your thought there, because we want to hear that.
All right, and the finish of the thought is, if you should miss next year's for some reason, now we no longer have another 38 years to wait, because we'll have another long United States totality coming up on April 8th, 2024, where the moon's shadow will start in Mexico, pass through Texas, and go not in this direction, but towards the northeast, pass over directly over Rochester, Cleveland, Buffalo. Good reason to go to Buffalo. Around the Syracuse area, and then finally to Burlington, Vermont, which is a lovely town, and it'll be total even there. So, in other words, in 2024, just a mere 7 years later, after next year's, we get another fabulous eclipse right in the United States. And if you want to travel overseas, we don't have to go so far as you guys have gone today to bring us this one. We're going to have several in Patagonia, in Chile, and in Argentina in the year 1990, 1920. We've already seen 2024 brings one in the United States, and then we get the longest one in U.S. history a little bit later on in the century, and the longest one of the century anywhere on August 2nd of 2027 in Egypt, in a very clear part of Egypt, although Egypt tends to be clear. So what I'm saying is that it's good news in the years to come. It's good news in terms of proximity, in weather prospects, and in how far you have to travel in order to see these. So if you get the hobby, you want to see future eclipses, we've kind of ended the hard times, and we're going to begin the easier times to see these eclipses.
And Bob, if one thing's for certain, if it's happening in the night sky or even the daytime sky like these eclipses, Slooh will be covering it. Bob, thank you so much for joining us today. It was absolutely wonderful to see you. We were delighted that you could join us. Thank you very much. Have you got any last words for viewers before we wind up?
Oh, I have no. I'm speechless. It's just beautiful. You guys did a fabulous job. How could it have been better? It was scientifically accurate. It was articulate. The skies couldn't have been clearer. And wow, I'd give you 4 stars for this coverage. Good work, guys.
Well, thank you very much. It would have been better if you'd been here, Bob. So anyway, we will see you back at Slooh very shortly, where you do your shows, and we all love them. You are the most popular person in the Slooh membership. So thank you very much, Slooh astronomer Bob Berman.
Thank you. Good night.
That was. I always love hearing from Bob.
I do too.
Now, Trish, have you got any final words for us before we wind up this eclipse, before we basically cook from the outside in?
I'm wondering if anyone has a mop, because I'm thinking we're gonna have to mop ourselves off of the roof.
Yeah, I think possibly when we stand up and the machines are even
very
hotter
hot, yes.
than us.
I was having trouble typing.
Yeah. So yeah, everything is a little bit hot. What time is it here?
It is 10:03 and 35 seconds.
10:03, and this is the heat that we have encountered every single day.
Although it feels almost a little drier, but maybe not a lot.
I think that's just because it's burning off.
That's very possible. Yeah. It's just evaporating as soon as it sweats out.
So anyway, Trish and I are going to attend to our 3rd-degree burns. Yeah. I would say to you this last message. If you enjoy what we do at Slooh, if you enjoyed our coverage today, if you enjoy this kind of stuff, if you enjoy sharing it in any way whatsoever, what happens in the night sky, come and join Slooh. You won't regret it. It's great fun. You're going to meet a whole stack of lovely, lovely people in the Slooh community, and you get to see not only events like this, but all of our member events as well, which are pretty cool. And if you're particularly interested in the sun, we have twice a week from our Slooh partner, the Prescott Observatory, live views of the sun using very, very special equipment there. And I tell you, they are absolutely awesome. What else, Trish, have we got coming up over the next week or so?
We have a few things coming up. We have, as you say, we have member shows all the time. Eric Edelman, who did that segment just a little while ago, has a show every Tuesday at 9 p.m. called Down to Earth, where he does similar shows, about 15-20 minutes long. And it's very encouraging of audience interaction, ask him questions, make comments. He brings all that into the show, and it's really great and fun. And we'd love to see more people in there. We also have Bob does a show twice a week. He'll be coming back to that soon. We also have Earth Sky News with Deborah Bird, where we get all the latest news from space. That's in the mornings on Mondays and Thursdays. We're adding a few more shows. We've got someone from the Vatican Observatory coming on to do reflections on space, because space isn't just about science, it's also about the human experience. And we have, of course, some events coming up. We are tracking the now no longer lost asteroid tomorrow night at midnight EST.
And Eric's doing that show because we're going to be in the air.
Because we are going to be in the air. We are flying very early in the morning here, which is very late at night on the East Coast.
And that's using the telescopes at the Slooh Canary Islands Observatory, right?
Yep, that'll be using Slooh Canary Islands Observatory, where we have actually tracked several asteroids, including some bigger ones like the spooky Halloween asteroid, which is a
Moby
great
Dick,
show,
the other lost
and Moby
asteroid,
Dick, the other lost asteroid, and a number of others. And if you ever want to watch any of these old shows, you can go back as a member and watch any old Slooh show anytime on demand right on the website.
Yeah. So, well, there is always something to look forward to at Slooh, whether it's the live shows or just the live telescope views every night. And don't forget, Slooh members, you can control those telescopes in Chile and the Canary Islands, so Northern Hemisphere and Southern Hemisphere. It's great fun. It won't be the same, will it, tomorrow? Just getting on a flight and carting all this equipment back.
Whole lives have changed.
Yeah, maybe we should just leave it here.
Yeah, let's do it.
A little bit heavy, isn't it? Anyway, listen, we hope you've enjoyed our marathon of everybody else has gone home. I mean, we are here absolutely alone. Not quite sure how we get back to the hotel.
But anyway, the ladder's still here.
Yeah, the ladder is here. We've got to climb off the roof with all of this equipment. Anyway, we hope you've enjoyed today. Please, if you support what we do, if you support what our mission is here at Slooh to share the night sky, please join us. That's all you have to do, and it really helps us out. It enables us to bring you this kind of coverage, and we've enjoyed doing it. Thank you, Trish, did a marvelous job.
Thank you, Paul, you did as well.
Ryan Little, we've got to mention Ryan
Yes,
Little.
we do.
Back in the Slooh HQ studio.
Running all of this, doing a two-man job by himself with
Yeah.
technical issues and handling them like a champ. So.
Awesome job, Ryan. Awesome job. And there are a whole stack of people behind the scenes. And finally, I would just like to give one last thank you to the university here, the Tadulako University, and specifically Professor Dr. Mohammed Basir CEO. He's the rector here. You know, we said it before, but they literally shut down the entire network on this huge campus so that we would have the bandwidth in order to bring you this live eclipse. So thank you very much to them. Thank you to you, all of you, for watching, especially if you've lasted until this last moment of the eclipse. We will see you back very soon. We hope you enjoyed the show. Goodbye for now.
Goodbye.